He asks, how do you explain night and day cycles on a flat Earth while accounting for solar eclipses?
Wow, that's a bit of a loaded question. Solar eclipses is begging the question fallacy that we dealt with at the beginning of the AMA. To assert
Yes,
that you've
sir.
got a formal logical fallacy, affirming the consequent, if the Earth's a sphere, then we'll have eclipses. We have eclipses, therefore Earth's a sphere. So that deals with that. What was the other half of the question? Night and day cycles?
How do you explain day and night cycles?
I
Yes.
don't have to. I'm not making any claims that revolve around my heliocentric begging the question fallacy that would infer that a rotating surface that we're standing on causes night and day. I don't make any assertions about night and day. I don't have any positive claims to make about it. If I was to be pushed to task about something that I must make a positive claim about when it comes to the sun, I'd point out that we measure it off a flat plane to give us our navigation system. That system, measured on a flat plane with the sun, is how our entire world has been plotted out on maps. Without exception, the sun's being utilised to navigate the world as a flat plane. But you want to ask me about how night and day works? Well, we've got a really complex system that we use in maps that uses time. We all reference GMT as a 0 point so we can know where we are on the world when we measured it flat with the sun. Well, so don't works. Well, yeah, rewind time to 2010. Maybe your question has some relevance as a straw man that some flat earther's going to offer a crap claim for as an answer with an azimuthal equidistant projection and some little lights floating around it. I don't do that. Your straw man fails when it comes to me because I'm not making any claims about what the sun is or how it behaves or what it does beyond its useful nature for mapping the world flat, which is what we actually use it for. So when it comes to practical applications for the sun, we practically apply it for navigation on a flat Earth. Hope that answers your question.
And we're off again. As usual, if you'd like to support this channel, there are PayPal and Patreon links in the info box below. It's going to be a great show today. I just got that feeling. And a show that probably should have been done some time ago. This is going to be quite interesting. But until we get to that presentation, I'll send it off to the master of ceremony, the distinguished Nathan Oakley. Nathan Oakley, sir.
Good evening, good evening. Just me, or does the live stream in Discord say that this stream is brought to you by Raid Shadow Legends? Is it just me?
I don't know what's going on in Discord, man. Is that what it says?
It says, this is brought to you by Raid Shadow Legends. Now, I am pretty certain that you have not been sponsored by Raid Shadow Legends.
I'm pretty sure, too.
What?
I think someone's just playing it in the stream. You?
I'm not.
Come on, admit it, you're a Raid Shadow Legends fan.
I don't know what the hell that even is.
I think I
Oh,
see
really?
Arvin playing that game.
Yeah, that's just something in the background. Just whatever. I'll turn it off, okay? Huh?
But it wasn't on Quantum Eraser Live, was it? You guys were all hooked up to that?
Yeah. It was only a passing comment. It's not particularly... We're never going to get sponsored by someone like Raid Shadow Legends, are we?
No.
I mean, the VPN people, maybe. They're a bit scammy. They might just about look at us and go, yeah, what the hell? In for a penny. Yeah, you can sell our VPN.
Yeah. Sure. Did you
Well-
like the intro video? Because we're going to go back to that. I just want everyone to know that before we get to the riveting presentation, we're headed back to that video that you put out. Did you put that out today?
I don't know what you played. I was in the live stream and it didn't play any audio. I don't know what you played at the intro. Sorry.
Oh, it was the sun proves the Earth is measured flat?
Oh, that's one of mine.
Yes.
Yes, I did release that today.
Okay. Yep. We're gonna head back to that here in a few.
Cool.
Super
Oh,
chat.
wonderful.
Super chat, super fluid, super mullet, super computer.
Free Palestine. Avoid globe lies. Have a globortion. It's flat. Little monkey.
That's a spinning space monkey, isn't it?
It does. It just looks like a little monkey.
You need to start spinning them. Thanks a lot, Free Palestine. Appreciate that.
So what was it about that video? Why that video?
Well, I'm going to point out, remember in the past I pointed out certain standards that have to be assimilated by flat earthers for them to be able to speak publicly about the subject and coherently and with some acumen. That example that you laid out today, that is the standard. And we'll go over that here in a few.
Okay. I thought... just trying to adjust my brain to that. I'm getting compliments for it, whereas I've been fielding comments about it that were very, very negative. It's like, if I can remember, because I've released quite a lot of videos in the last few days, I'm very poor. So I've been... Basically, that's my version of e-begging, is putting out lots and lots of videos. Anyway, if I remember correctly, in that video, I'm being put to task on night and day and eclipses.
Yes.
And I essentially go, no. but mapping, and everyone in the comments is like, oh, so you're basically saying you can't explain night and day.
Yeah, we're gonna deal with that exclusive. Do you want me to deal with it now?
I mean, as we're on it, only because I've just remembered what the video is about.
Yeah, you shouldn't be getting any comments for that. Flat Earthers, listen up. If you've been out here for 3 years, that's my little arbitrary cutoff point, and you don't answer that question real close to how Nathan handled it, then you need to put a cork in it. Okay? Now, you can talk to your friends and in private discussions about your feelings and whatever. All right? But if you're out here publicly speaking, representing Flat Earth, and isn't it real close to what Nathan's put out, and I'm in the near vicinity, I'm not going after the BALLTARD. I'm going after you. Just to let you know. That is the standard. You don't have to explain anything. Number one, explanations are useless. They're worthless. I can get explanations down on the corner, the village idiot, they're a dime a dozen. Explanations are worthless. This explanatory power is horseshit. Get that out of your mind. Without validation, an explanation is absolutely worthless. Number one. Number two, if you didn't make a positive claim as a flat earther, you don't have to explain squat, right? Now, the idiot BALLTARDs do, because their scriptures are already concretized and given to them by their pseudoscience priests. You know, the heliocentric BALLTARD spinning space monkey priests? And their gospel is that religion. Their answers are already given to them. They're handed to them, right? They're implicit. And they're, like I said, they're already gospel, so they must answer them. And yeah, let's all be real. 99% of them don't have a frigging clue about their own gospel. But that doesn't apply to you, right? You don't have a gospel. You don't have a religion. The only claims that you need to stand up for are the claims that you explicitly make. Does everyone understand that? It's a rhetorical question. If the BALLTARs don't, they're not going to get this, right? Ask one of your fleet of slobber nurses to explain the concept to you. Okay? So let's just play this again, because we're right on time with it. So let's do it again. Pay real close attention.
He asks, how do you explain night and day cycles on a flat Earth while accounting for solar eclipses?
Wow, that's a bit of a loaded question. Solar eclipses is begging the question fallacy that we dealt with at the beginning of the AMA. To assert
Yes,
that you've
sir.
got a formal logical fallacy, affirming the consequent, if the Earth's a sphere, then we'll have eclipses. We have eclipses, therefore Earth's a sphere. So that deals with that. What was the other half of the question? Night and day cycles?
How do you explain day and night cycles? Yes.
I don't have to. I'm not making any claims that revolve around my heliocentric begging the question fallacy that would infer that a rotating surface that we're standing on causes night and day. I don't make any assertions about night and day. I don't have any positive claims to make about it. If I was to be pushed to task about something that I must make a positive claim about when it comes to the sun, I'd point out that we measure it off a flat plane to give us our navigation system. That system, measured on a flat plane with the sun, is how our entire world has been plotted out on maps. Without exception, the sun's being utilised to navigate the world as a flat plane. But you want to ask me about how night and day works? Well, we've got a really complex system that we use in maps that uses time. We all reference GMT as a 0 point so we can know where we are on the world when we measured it flat with the sun. Well, so don't works. Well, yeah, rewind time to 2010. Maybe your question has some relevance as a straw man that some flat earther's going to offer a crap claim for as an answer with an azimuthal equidistant projection and some little lights floating around it. I don't do that. Your straw man fails when it comes to me because I'm not making any claims about what the sun is or how it behaves or what it does beyond its useful nature for mapping the world flat, which is what we actually use it for. So when it comes to practical applications for the sun, we practically apply it for navigation on a flat Earth. Hope that answers your question.
You get it? Any questions out there? If you do, just PM me. Then we'll deal with those. Good? I thought so.
Cool. There's loads of those. I'm going to release them over time. I've already edited about 10 out of the AMA. And obviously, I think they're all good. I didn't particularly single out the sun question one as being a really good one, particularly. I think they're all up to a really high standard.
I did, for a working example.
Cool.
It was very satisfying. It was awesome.
It just surprises me that the people in the comments made me feel like I'd done an incredibly poor job. I've got to be honest. I'm not saying I took it to heart that the commenters were saying, oh, right, so basically what you're saying is you can't explain day and night and you can't explain eclipses. That's basically what you're saying, is it?
They would.
Well, super.
Because it is so devastating.
Flat C.
Superchat.
Superchat, superfluid, supermall, and supercomputers.
Yoda. A donation towards Arwen's birthday cake. I don't know what that means. Is it your birthday?
Your birthday, Arwen.
In 3 days.
Your birthday today.
Yeah, and that very funny.
All right, we can't hear you, Arwen.
What?
Can't hear you.
Why not?
Is you
Because
too
you're
quiet?
something's wrong with your mic.
All right, well, it may or may not be Arwen's birthday. If it is, happy birthday. If it's not, get lost.
Yes, I
I heard him
agree.
say-
If it's his
I
birthday,
heard him.
happy
Lumpy,
Oh, well, jolly good.
Lumpy, you just entered Thunderdome with your mic open.
Sorry.
Go on, Moot.
Hold on. How's my sound?
Oh, that's better.
Is it your
All right.
birthday today?
No, in 3 days.
Okay, well. Close enough. Well, happy birthday for 3 days' time.
Thanks.
And then we have the mighty principal in here for today. We have the distinguished Adam Meakin. Evening.
Evening. Evening. Evening, QA. Evening, everyone.
Evening.
good to see you.
I don't know. Do you have a
Evening.
presentation for us today? We would never know that it's yours.
Well,
I would-
come on, let's address that. Okay. So what are you seeing there? Well, unfortunately, this is a consequence of history. All of the slides where you see that logo, there used to be an Iron Realm logo there, but I didn't think it was appropriate to use anymore. Not being a member, so I as I said to you, I need to quickly go through the slides, and that became apparent that was false advertising for me to actually present it now, that logo.
Okay.
So that's why that's there.
All right. Fair enough. That's pretty damn good explanation. Thank you.
The reason people may not get that is he's been ribbing me like I'm some kind of egotistical maniac. Putting my logo everywhere. I'd have sent him the slides.
We don't need any backstory, Adam. We know why you did it.
We're getting a presentation out of you today, Adam.
Yeah, I don't know why. It's probably born out of the past week and chats we've had. And then QE said, well, we should do this because I think Brian, I think I might have seen him there earlier, and Refracted said, well, that's quite good. We've done it. Nathan Oakley and Adam Meakin taught balls many years ago.
Oh, I remember that.
Yeah. It's just my derivation of a formula. And just a little bit of comment on 8 inches per mile, really. We thought it was probably pertinent. It seems to be popping back up. 8 inches being used. So I thought I was asked to go over what I did back then, which was part of my journey, I suppose.
Sure. We got the
This is a-
BALLTARD stepping away from, the foundational religious claim that was concretized in their scripture. They don't understand geometry, that we can actually calculate the curvature of the earth, right? So we're going to put it to them. Now, there's an issue out here about the 8 inches per mile squared. The feeble comebacks they've had over the years for that. You can only see it over 100 miles. That's all it's good for. So I brought up the late George Hanutchek, even though he was a little bit out of his mind on some things. His geometric and mathematical acumen was never in question. And he put out a video some 4 or 5 years ago. He was getting absolutely frustrated with idiot BALLTARDs, namely Soundly, Professor Phil, and Timmy Clown, about them stumbling, bumbling, and fumbling around with it's only an approximation. And then George put out a detailed over an hour presentation going every step mathematically how 8 inches per mile squared was pretty friggin' accurate. And Adam came along and he said, wait, I got something even more accurate. And then we're going to fight a little bit about that today. And I thought that was a good subject to bring up, so there's no question about what their gospel says, or what their gospel should say.
You got to the
Super chat.
Superchat, Superfluid, Supermolid, Supercomputer.
Liz, the Iron Maiden, I think her birthday's the same birth. She shares a birthday with Arwen. So happy birthday to you and 3 times also. And free Palestine. Don't let Grandma die as a globber. it's Globortion time. Happy Flatter Day.
Thanks, guys. Appreciate
All
it.
right.
Yep. Is that it?
There is another one.
Oh, hold on.
Yeah, that
That's it. Okay. Nathan, sir.
There's a certain amount of ambiguity with this 8 inches per mile squared, and I only know this because I was privileged to do the show with Adam about 6 years ago. So, I just want to get a different type of confusion out of the way first of all because of what you've just said. So I was really pleased that you went straight to George Netchuk, because that description, I remember you giving it, and it does stand directly in conflict with what Adam's about to go through, and you know that, so you've disclaimed it straight away. Now, who's more right? I already know it's Adam. as much as you referenced George Netchuk, and but by the same token, George Netchuk and you are also correct when you say that's about as accurate as you're going to get. It's about as accurate as you need when you're making a ball claim.
Sure. Using
the word accurate to describe non-existent all Earth maths that we don't experience in physical reality, when they say we should experience it at 8 inches per mile squared, is a bit convoluted. But I just want to make 3 things clear. Number 1, there is no curve, there is no 8 inches per mile squared or any other derivation of that. Number 2, 8 inches per mile squared is absolutely your rhetoric, and it is the claim of the ball Earth curvature. Number 3, it isn't exactly right when you use a radius of 3959 to derive any value. I don't think there's any that will sit perfectly in line with 8 inches per mile squared. Therefore, it isn't right, and when Toon uses an excuse for losing by saying it's just an estimate, or whatever he says, soundly, not Toon, that's just complete cop-out.
Yep.
And when you're saying no, you'll stick to your rhetoric. In that circumstance, is absolutely correct. It's not that Adam's going to undermine John's.
He's not.
Adam's in no way going to undermine John's position when he comes to pointing out that ballers will try and shy away from their own bloody claim when it fails.
Yeah. It's not. It's in perfect hand grenade range. But Adam's going to get more precise. I don't have a problem with that. But in the context that the ballers need it and we use it, 8 inches per mile squared is plenty good enough. And you're going to see that. Superchat, Superfluid, Supermall, and Supercomputer.
Sorry. Billy Philly, 22. He said, thanks for vouching for me at 24/7 QE. Appreciate you.
Yeah, not a problem, Billy Philly. Got you covered. Thank you very much, sir. Go ahead. Anyone?
Well, the last thing was that you said that they would argue, it's 800 miles. I'm a sharer again without stealing Adam's thunder too much. It's in terms of how closely it matches with their actual formula. It's more than 1,000 as far as I'm concerned. But again, I'm stealing Adam's thunder.
Yeah, we're stealing Adam's thunder. I'll just give it. Go ahead, Adam.
Not really. What you make there was quite interesting with regards to refracted. He did obviously throw this at me, and I defended it, didn't it? But I'm not. There's no claim here. All I'm doing is explaining their claim properly, accurately. Yeah. So there's no claim here. There's no attempt here for me to tie this to reality. Yeah. It's just making sure that when they make their claim, it's commensurate with their R value, as opposed to it not being commensurate with their R value, which was my beef early on. That's wrong. And that's what you'll hear lots of people say. That's wrong. 8 inches per mile squared is wrong. As if that's going to mean that it is a ball, really. Now, after you've shown a ball at reasons why 8 inches per mile is not demonstrable in reality, we'll go, well, it's because their formula's wrong. Therefore, so, it's a point of I can just ignore it. It's not the case. 8 inches is quite forgiving. Or as QE says, in reality, as far as you can tell with the naked eye, perfectly permissible. And a great rule of thumb, QE, yeah? And that's fundamentally what 8 inches per mile squared is. It's a rule of thumb. It's not an accurate formula. And what I'll do tonight is provide an accurate formula.
All right.
Based on their claim.
Okay.
Can I give a quick analogy? I've just tried to rack my brains for one, and I think I've come up with quite a good one to start you off before you get into the details of it. Right. So it's a guy that's standing at a petrol pump arguing with the owner of the petrol pump. And the guy's saying, look, when I put the petrol in, I count in Mississippi's because I know roughly the flow rate, and I just, by thumb, a rule of thumb, know how much to charge you based on how much time you've had the nozzle in. And the guy goes, it's by the litre! I want to pay by the litre. I want to know exactly how much I've paid for the petrol. And they argue back and forth about whether or not it should be by how many seconds or by per milliliter. And then a third party comes along and goes, haven't pumped any fuel. There's no fuel in the tank to worry about how much it's going to cost. There isn't any fuel being pumped. There is no fuel involved. Why are you arguing about whether or not it's per gallon or per litre or by how many Mississippis you've counted as it flowed into the tank? You haven't filled up any fuel. But to put it into contrast, it's whether or not it's 8 inches per mile squared or a derivation of the R value that works perfectly. There isn't any Earth curve. There you go.
It's a good
Perfect.
analogy.
Perfect. Yeah. Remember that if you're going to attack me for any claim you think I'm about to make in this. Yeah. It's key. This is just about describing their claim when they say they're putting fuel in at this rate, liters per minute, and actually you can guesstimate that by how many seconds you think you. Yeah, that's perfect, Nathan. Yeah. No fuel went in. Before you start my slides, QE, based on the preamble, I posted 2 pictures in Skype.
That's off production. You didn't give them to me in production, dude.
Yeah, you're right.
Damn Skippy,
am I able? Can I post them?
All right, yes.
Somewhere, or can you access
I
them?
got you covered, Adam. I'm glad you brought this up because you know I was going to bring it up. So I'm glad you anticipated what I was going to do. Hold
Absolutely.
on.
And if he didn't bring it up, I was going to bring it up. And if he didn't, and Adam didn't, and he didn't, Arwen was going to.
Exactly. So
Hold
thank
on,
God we're on
Adam.
the same page, guys.
Hold on, Adam. Let me go ahead and share my screen. Let me take your presentation up. Stop streaming. And let's get this up. 1 second. Here we go. I'm going to put George's up right.
Perfect.
Right. Where'd it go? Hold on.
Yeah, George is up.
George's is up right now.
Okay, so we mentioned this earlier, and I have bothered to watch. I have bothered to watch this video of George's, and I can mathematically I can't fault it. I mean, he's reading off a script, and I don't bloody blame him. It's really long, boring, complex derivation. To critique it, and see, this was available to me, and I wasn't happy with it. This is where you get 8 inches per mile from. And there are certain assumptions. The assumption being, you see where that curvy line from the top of Y down to Y prime.
Y prime, right here, this curvy line, the BALLTARD?
Yeah. Mathematically, that's a straight line, okay, in the way they're going to resolve this. And the way they resolve it is using Pythagorean theorem. So if you just take the top line, like x squared plus y squared equals re squared, which is what we all know, and that's the methodology of resolution. Now, that's the critique of this, but that there's nothing wrong with that. That's the methodology. So there's no attack on George. What George does is give a very detailed derivation, which is correct in every single way of the derivation.
Yes,
so
sir.
Shout out to George. Rest in peace. Yeah, you've provided a perfect explanation, and I can see why it annoyed the ballers, because if you listen carefully, like I say, there's a reason to object, and that it is this approximation. It's 1, 2, 3, 4. I've put 4 liters in my petrol tank method. Yeah. All of this is done in a way that is done. If you see, look what's happening. Everything's done on the outside of the ball.
The outside of
Creating
it.
things.
Yes.
Yeah.
Yep.
Which is where I had problems. And if you go to the next slide, and I'll move on from George, because I say maybe we can post that link, because it's out there, and it's a really good watch if you're a geek. And it's like I say, a really nice derivation and explains it fully.
Goodness gracious, this is a terrible rendering of this. Where'd you get this?
I just pulled it quickly because I was just trying to think, because I wanted to put a bit about George, and I thought I want to link it to that. So it doesn't matter, you can't read the details, but anyone that was out there in 2016, 15, this was the table you were all given at first. And
yes,
if you see again, what we're trying to do is resolve triangles and approximate them to a sphere, and that's all it's doing. Again, on the outside, and again, it's kind of wrong.
I just want to make it clear to the audience, when you say outside, all of these measurements, can you go back to George's slide?
yes.
I just want to make it 100% clear what he's talking about. George shows it. There's a triangle at the bottom that he's showing that would slip onto the top. See where he's got that triangle at the bottom? I don't know if you can circle that with
Down here?
There you go. Yeah, that's, if you imagine that sitting on the outside of the sphere for the derivation to take place. It's not being done
My
inside.
God. Have you been taking math pills? Like I said to you the other day when you described something beautiful. Have you just spotted that, Nathan?
Yeah. Well, I've watched this video before, though. Watch George's video.
Yeah. Well, respect. Well, that's the crux. Yeah. You can see that the line C, the hypotenuse, isn't in the big picture. Hypotenuse, is it? It's Earth curve. Right?
Huh?
I'm honestly, mate, that's wicked.
Line C is not the hypotenuse down here.
It is in that right angle triangle in the way that George is going to resolve it.
We're going to have to
Shows you at the
define
top.
hypotenuse.
He's showing you at the top, right? See where he's got it drawn out along the top with X and Y.
Right.
That's where Adam means on the outside. He's using that line that's taken from your, if you want to call it, tangent point at the top at Y that goes down through R, out through X, and then down again on the outside edge through Y.
Oh, brother. Whatever.
No,
Continue
but
on.
Anyway, sorry, Adam.
No, but that's really a key point to the inaccuracy. So it makes it harder, certainly from my point of view, to do this on the outside of the sphere, because we're having to deal with geometric creations outside to reference it to the surface of that circle, or the circumference of that circle. But there's then this secondary approximation, which means we're not going to be right, because we're going to try and use Pythagorean theorem, as in that little thing at the bottom, where if you've got X, straight line, well, that matches with the top. Y prime, that matches with the top, straight line. C now is a straight line between line X and the Y intercept and Y prime to R. But as you can see, it's depicted mathematically as a straight line C.
Yeah.
If you look at the top diagram, it's not a straight line, is it? It's Earth curve. That's what we're trying to measure. You can see this is one of my points of, well, that's not right. If you're going to describe, see, maths is a way of describing things, isn't it?
Exactly.
At best? Right? So if you're going to describe it and you recognize your description is wrong or has mitigation, then you've got to appreciate that. And if you want to be more accurate, then you need to describe it more accurately.
More accurately, if you want to be more accurate. That makes that. Thanks, Adam.
Well, we're not. Yeah. Right. Anyway, they're the pictures. Maybe if we just start the slideshow.
Okay, you're going to have to give me a
With-
second. Just give me a moment. Yeah.
We can go to slide 2 unless you want to. familiarise
Just give
people
me
with
a
my-
moment. Okay. Just wait 1 second. I got to change this up so everyone can see it in. Let me make sure it's up. All right, there you go. And let me change it. Have to do this.
Something amusing while you're doing that. About, I don't know, a few weeks ago, my wife and I were discussing our kids' education, and it came to in this, basically figuring out triangles, SOHCAHTOA and all that. And she says, when is that ever going to be useful? We got taught it at school. When is it ever useful? I'm like, I'm sure it's got some practical application somewhere. Debunking Earth curve.
Yeah.
That's about slide 9. SOHCAHTOA comes in. So, yeah.
Okay, I'm ready, Adam. Like I said, I was confused on who was given this presentation, but I think everyone's clear out there now.
You sure? That'll be me. Just in case.
Okay, from this point forward, as Adam is actually in the middle of the presentation, we're all giving colour commentary. And by all, I mean me and Quantum Eraser. I think you should all shut up while he's doing this. It's very rude.
Evening.
Evening. There is a point, and I appreciate that. What I would say is, if there's a point where genuinely you go, I didn't get that. Now, hopefully there isn't, because it's pretty much step by step. But if there is, interject and pull me back.
I don't think there will be on my part. I'm going to let you go through the entire presentation, and I'll probably just have one question at the end. That's what I'm anticipating. So you're not going to get interrupted. I won't interrupt you.
I don't mind if it's a point of requesting clarity rather than arguments. Please say for the end.
Okay.
But if it's a point of clarity, then by all means, anyone. I'm happy.
Yep. It's off. Okay. Adam, it's all you.
Slide number 2, please. Okay, so why? And this is important. When I started this journey, I can guess I'm a bit mathsy. And one of my common law friends, like one night, told me the Earth's flat, and I laughed. And I went off to prove it. An Earth curve was one of the first things I picked up. And I realised 8 inches per mile squared, it was wrong. And at that point, I'm thinking, well, if it's wrong, how much is it wrong? Yeah, I want to know. So that's kind of what I went off to do. And we were doing that on Iron Realm. And at that point, Jaren was shouting the same thing. These are early questions. If 8 inches per mile squared is wrong, what's right? And I was even pre-YouTube back then. I'm dealing with guys on Twitter and stuff in Germany and stuff, trying to do a few formulas. And I'd done a number of things up until this point. The first one completely wrong, because it was just geometry. And at certain points, it worked very well, this formula. At 90 degrees, 45, and subdivisions of. But at other points, it still didn't work. And I couldn't figure out why. Then I went into doing vectors, and I was able to model accurately the purported ball geometry with vectors, but obviously vectors require straight lines. So I had, in effect, a polygon of 40,000 sides, and at every point of the polygon was correct with regards to, and more accurate than 8 inches per mile. But what I couldn't do without creating more polygons was make it more accurate in between each kilometer. So that created a problem. And as it says here, if you got to presuppose, do it accurately. And ultimately, this should be useful for flat earthers and ballers. If we're going to argue a nuance, it's just, like I say, do it accurately at least. Next slide, please, QA.
Yeah, I'm going to interrupt right now. This 8 inches per mile squared formula is an approximation and not accurate for any distance. It is close up to 100 miles. That's horseshit.
Okay, I'll explain that if you wish. So, and the best place to go is George with this, because he'll go into this. So this is a parabolic function, which at the point of up to 100 miles, it has its closest fit to the supposed curve of a circle of a radius 3959, and this is where you derive this. So when we criticized earlier that Earth curve bit trying to be the hypotenuse, if you take that function as the parabola, it's a bit straighter and it's close. It's pretty much really close to it, so you can use that to derive it, and that's kind of what George goes through. I don't want to go into their thing too much, because it's describing how and why it's inaccurate, but just assume that it's not accurate because it's an approximation using a parabola as will be described.
Okay, I'm not going to interrupt you anymore. Just go. So you want the next slide?
No, because this point's worth exploring. So 8-inch per mile squared formula is an approximation and not accurate for any distance. I'll stand by that statement. There's no point. There might be one point of tangency or intersection between the two curves where they do match up exactly.
Yeah.
There has to be.
Yeah. Define accuracy.
Where the two curves meet at one particular coordinate point, so the parabola point and the actual circle circumference of a 3959, there will be a point where those two meet. As for everywhere else, there is variance.
Yeah, how much? Yeah, we're going to get into the accuracy later. I'm not going to interrupt anymore. Let's go.
What about super chat?
Just hold on, Adam. The super chats and the super fluids, just hold them till the end of the presentation, please. Okay. Thank you, Adam. Next slide.
Yeah, please. Yeah, it shouldn't be too long. This is the. Okay, so this is QE's favorite bit. Tell him what you're going to tell him, and this is that bit. Then I'll tell you, and then I'll tell you what I've told you. So, what are we going to do? And hopefully this means that this should limit the question. So what we're going to make an Earth curve calculator. And things we're going to do, we're going to assume the Earth is a ball of radius 6371 kilometers, and I'll be working in metric units. Certainly for the most part, it's easier. Calculate the number of degrees in 1 kilometer of a circumference travel, i.e. traveling across a ball. Define mathematical definition or drop or curvature created by travel. That's going to be important so that we can describe what we're doing. Use a diagram created to postulate the premise of the formula. So you look at the picture and figure out, well, what am I trying to work out here? And then we'll use a bit of trigonometry to calculate the triangles we've created, and then combine all those statements of truth we've made and the bits of trigonometry, put them all together to create the curve calculator. Next slide, please, QA. So the first thing we're going to assume is we're on a ball. And if we're going to do that, we can create a great circle route. That's a new buzzword. And in doing so, we'd travel a circle which will have 360 degrees. Now, if we assume we've got a radius value of 6371 kilometers, that gives us a circumferential value of 40,030. I've just taken a quarter here, so if I divide that by 4, that gives me 10,007 kilometers. And what I'm trying to do now is just figure out how many degrees there are in terms of to be expressed per kilometer of travel on this circumference or great circle route. So in 90 degrees, there are 10,007. So in 1 kilometer of travel, there's 90 divided by that same amount. So I could express angle A as equal to 0.00899,32161, which I'll refer to as 0.009, hopefully moving forwards. Next slide, please. So this is what I've just worked out, isn't it? If I know that I've travelled X distance, I can then figure out angle A in relation to that as a distance as circumferential travel. So we can say that angle A is equal to the distance we think we've travelled times 0.009. That's a way of expressing angle A. Next slide, please. So the next thing we need to do is kind of trying to define mathematically what we're looking at and how we could express that in algebraic terms. So we're assuming, and at this point, I don't need to assume I'm on a ball. You know, it's up to you to assume you're on a ball. I'm just trying to express this with regards to circles, travel, what would happen if you're traveling on a ball, and rates of change. So it's defined by the yellow line, the yellow horizontal line determined on the axis, if you see across, to create a D1, which was what we'd probably call drop. If I've travelled distance, which creates angle A. That's the point where I stop. And if I come across, and this is where refracted light, are we using flat planes here? And I'll address that later. I do recognise it. You can see that we create a point of intersection with our R value. The drop can be expressed as a distance against this initial radius, vertical red line. And that allows us to make a mathematical statement. We could say that D1 plus D2 is equal to R, radius value. Next slide, please. So we can't simply define D1, but we can easily define D2. And that's part of the trouble. If you think about George's problem doing it on the outside, I look at D1, I've got two straight lines and a curved line. I can't do anything with that. Can't work with that. Yeah, because the rate of change of curve of that circle is a very difficult thing to deal with. But if I work with inside the ball, I can create a different triangle. Exactly. Where I'm using D1, I'm going to try and define. Sorry, I'm going to try and define D2 instead of D1. Next slide, please, Huey. And now, there we go, Nathan. We can use trig to find D2 because we've got certain things. We've got an R value, the radius, which is the point where we've stopped walking, or the point in the distance. That will still be R. Wherever that R value is, wherever that point is, it's going to be R on the circle. D2 is that point of intersection with our initial R value. And so what we've got there, and we've got angle A. We know, which we worked out earlier, is which we calculate from the distance walked based on the pre-assumption of the R value. So we've got a hypotenuse and an adjacent. And using silly old hens can't always have their own acorns. And we identify that it's adjacent on hypotenuse, so we can use cosine. So next slide, please. So using trig, we can now define D2. Now, we don't want D2, but we know certain things about D2 will help us find D1. So let's use a bit of trig to define D2. So if we take that standard trigonometric function, we can say that cos A is equal to the adjacent over the hypotenuse. And given that we know the adjacent and the hypotenuse, what they are, we can substitute those to make the statement that the cosine of A is equal to D2 divided by the radius. Useful, brilliant. What we actually want to do is have a descriptor of D2. So if we just rearrange that formula, we can make the statement that D2 is equal to the radius multiplied by the cosine of A. Next slide, please. So now we've got, I think, pretty much everything we want bar D1. But we do know that D1 is derivable by taking away D2 from R. So next slide, QE, please. So at this point, hopefully you can kind of see where we're going, what's going to happen. We've made a lot of statements and derived a little bit. And I just want to redefine those statements we've made. We've made statement number one, which is that D1, which is the thing we're looking for, that drop amount after traveling so much, it can be described as the radius minus D2. And we've said that D2 can be described as the radius multiplied by the cosine of A, where A is the angle created by the distance travel, where the angle A is calculated by the distance expressed in kilometers multiplied by 0.009. Next slide, please. So given that D1 is equal to the radius minus D2, we're just going to put all this together and hopefully come out with our formula. We know that d2 is equal to the radius multiplied by the cosine of a. So if we substitute this into the equation, we can make the statement that d1 is equal to the radius minus the radius multiplied by the cosine of a. We know that the radius in kilometers is equal to 6371 because we're dealing with their claim. Their ball, this is what they claim. Yeah. Up until this point, this is just geometry. This is just put any number in. You can do this exactly same thing on a roundabout. It doesn't matter. This works. But now we're putting it into the ball claim. So we know that the radius is as they describe, and we can now substitute that into the equation. So now we can make the statement that d1 is equal to 6371 kilometers minus 6371 times the cosine of angle A. And we know that the angle A is equal to the distance in kilometers multiplied by 0.009. We can now put that into the equation. Next slide, please, QA. We can have now a derived curvature formula for drop, which would be, when expressed in kilometers, equal to 6371 multiplied by 6371 times the cosine of the distance times 0.009. And I'll explain this a little bit. Next slide, please. Now, when I did this back in the day, like I said on Iron Realm, Rob was Australian. He went, "What the hell, mate?" So, and the strange thing is, Brian did the same until I showed him this slide midweek, and then he went,
Just keep going. Just keep going.
Yeah.
I mean, there's only so much I can keep up with.
Nearly there. This is the point of how you do it. So, obviously, in the past, it's easy to 8 inches per mile. We can all do that on a calculator. But if I throw that formula at you, if you're not used to dealing with trigonometric functions, it can be a little intimidating. But this is the Aussie rules. You take the distance. That object at oil rig is 6 kilometers or 9 kilometers away. Multiply it by 0.009 to give you A. Find the cosine of that angle. You go cosine of whatever you come out with. Multiply that cosine by 6371. And then take 637 away from it. That then gives you your drop in kilometers. Next slide, please. Next slide, please.
Adam, I have to say, I didn't review this. I like where you're going with this, just to let you know.
Okay. The final point is that's where we're at. This obviously was expressed in kilometers, so we can do the same, and I won't go through the repetition, but if we just go to the bottom line, to do it in miles, would obviously change the equation, not the derivation. So all you'll see is a change in numbers. So if we're going to do it in miles, it's 3959 minus 3959 multiplied by the cosine of the distance times 0.0145. That will give you the drop in miles. So you've got to multiply by that 5,000 odd to give you feet. But this, and I'm done now, but this is an accurate way of expressing their claim. Now, there are nuances where that become apparent, particularly when you're looking at pictures and stuff like that. And actually, when you get to some significant points, you're looking at 10, 20, 50, 100 foot differences in the 8 inches per mile claim and this. Always in our favour, yeah? Like I say, if you're going to presuppose, I like to be accurate. Thank you, I'm done.
That's an outstanding presentation, Adam. I got a question for you, though. To make it easier. Go ahead, Nathan, you want to get in here, what?
Oh, I want to point out why they would not do this. Why would they take it to an approximation that's inaccurate and only matches at one tangential point, as Adam described it? Why would they do that for convenience or anything else in practical application? Can anyone spot where the problem is? There's one particular part of this equation that is impossible to derive for a baller that's just claiming a distance and wants to tell you how much curve there is. What bit of this can't they get?
Obviously, the radius is a problem.
Well, yeah, that too, but working within their paradigm that we do have a radius to work with, there's another bit that they can't get. In this instance, it's 90 degrees. isn't it?
Yes.
So Adam's picked a point arbitrarily to make the maths easier to do, and he's saying 90 degrees because that's to an equatorial value that is understood and known to be 90 degrees. But for all other instances, they can only start their process to make their claim that there is a curve that you're going to be describing with a value based on one value that they can actually give you, which is distance. That's it. So they need something to work with a very limited base to start with. That's why they've done it. I just wanted to slip that in for anybody who's questioning why wouldn't you do it this way. Oh, I'm sorry, Adam.
It's funny that 5-6 years ago I bothered to put it as 90. Why? Right, all those years ago when we didn't have celestial navigation, we didn't understand that. Have I bothered to express it as a right-angled triangle? I don't know, because it's odd, isn't it? That I can't make any like kudos from it because I don't know why I did it. Because I should have just took, the radius value 24 and divided it by 360. Same when I did it the kilometers. I've bothered to change it to a 90-degree flat Earth elevator.
You had to do
weird,
it.
That.
You had to do it, but that's connected with the radius. Like I said, I knew because the 90 degrees jumped out at me, but you have to do it that way. There's no other way he could have done it. I'm talking about Adam, right? You're going to need a triangle to apply the trig functions. You're going to need the 90 degrees. You're going to need a right angle triangle, period. Yes?
Can I say something?
In terms of, I just want to add, it serves its purpose though, doesn't it? It shows where it's and how it's inaccurate.
All right.
Yes, and if you look at Metabunk, and if you look at Walter Bislin and all that, they don't use 8 inches per mile. You can use my formula, check it, and go to Metabunk, and you'll see that we're within, I think, the 5th or 6th decimal place is where we start to disagree.
Oh, wow.
So, yeah. So it's there, it's usable, it's accurate, and that's what the ballers use now to be accurate in their claim. And it's not to attack 8 inches, because if I'm looking at Blackpool Tower across the beach with my eyes, I may as well use 8 inches per mile. Don't need, as long as I can do squared functions in my head, then I can use my brain to figure out how much supposed curvature I'm not seeing right now.
That's where I was going to go next, but Brian's in the queue. Go ahead, Brian.
Go ahead, Brian. That was a good one, Adam, by the way.
And how much curvature has been concealed by refraction?
Oh, Brian, your voice has changed.
Oh, yeah,
No,
sorry.
that's certainly not me. I'm loyal to people.
Hey, Brian.
Yeah, okay.
All right.
This is why I wasn't in, but I'm here now. But anyway, Adam said, and Brian did the same thing as his Australian friend. No, Brian did not. Brian understood every part of it, but Brian said to you that he can't do, because he was never shown how to do, sine and cosine, because Brian left school very early.
That's what I said on the calculator. I said how to do it on the calculator, and that's when I wasn't calling you as thick as an Australian. I promise. This could be the only intonation you could take from that.
And he
you
took
racist.
it.
Yeah.
Yes, and he took that. Yes, he's Irish, for God's sake.
Yeah, well, I'm naturally thick about things, but no.
You're not. What a garbage statement. Right. Over the last week or two, I've had to disclaim where I sit in fear of your intellect as it's greater than mine in many, many examples. And here you are going, oh, I feel thick about things. Yeah, get lost.
No, that's thick is like stubborn or awkward. Stubborn or awkward. It doesn't mean that you're smart or stupid. It's just if you're being thick about it, you're being stubborn or awkward. That's what it means.
No, fine. I didn't know that was. I'll take it completely back then.
Phrase.
No, I'll take it back. Take it back.
Yeah. But by the way, I'm not. You keep on saying I have a better intellect than you. I don't. It's that I put in the effort to learn the details, and you don't. That's
and you don't. That's a good one. I like that one. And you don't. Good one. Okay, so specifically with this, with the Imperial for Mr. Savage, or the previous slide, please.
Yeah. Well, it's actually very easy. It's actually very easy to learn. well, as you do exactly as Adam says with the cosine on your calculator. It's actually very easy because all you're doing is establishing the distance in degrees. That's what you're establishing. Then you have an exact arc length, and then you can you then have an angle, and you have from a center, and you have one length, which is the radius. Go on, Adam. Sorry.
Oh, just as you're going to say that, just pull up the previous slide, Aussie rules, not Irish rules. You'll notice I didn't bother to change it. But this is the point, yeah? So you take your distance. What am I looking at? I'm looking at platform A. And multiply however far that away is. And in this case, we're in kilometres. Because their road signs are in kilometres, the Aussies. And we multiply that by... And I've put 0.09. I'd use those decimal places. You know I would. You know, there's no way I'm not.
Yeah, we know.
Yeah, but do it. It's worth it. It's worth the extra second. Whatever that turns out to be, it equals A, right? Then you press memory plus, you save it, right? And then you press cosine, and then paste, and then press equals, right? Then you times that by 6371, and it equals it. Then you minus 6371, right? And this is the nice thing, because it gives you a minus number, which is technically correct, which I kind of like, yeah? But that's it in kilometres. Now, you want to know that in metres? Ask Nathan Oakley what you do to that number to turn it into meters.
I wouldn't know how to convert it. Sorry, my bad.
Yeah. And because you don't, it's still a ball, Nathan. That's the point, isn't it? Yeah. Times it by 1,000, then you know how many meters of supposed curvature you've not witnessed. You can still see the bottom of platform A.
Yeah, you got there before me, and then Arwen bolted it up after. Yeah. So if you want to know more accurately, when you see a lighthouse that shouldn't be there, how much earth curve there would have been blocking it, this is the formula for you.
How far the hill is back.
Very well done. Brian, do you have any more comments on this? Let's go to anything with the Imperial for Mr. Savage, or no?
Well, something I want to point out is that we are calculating these things out in kilometers and statute miles, but they're not arc lengths, are they? They're straight lines.
No, that was something. That was another point I was going to raise. I got a real frog in my throat. Hold on 1 second. The only other way, when I critiqued it for the 90, which he's going to need anyway, I was going to ask it as a question for Adam. If you understood the principles and you're using it in, I don't know, statute miles at 69 for a degree, and you're deriving it from light movements, can you still apply this? In other words, if you don't have that right, I think I've already been answered by QE because he was like, no, he had to do it that way to have a right angle triangle. If you had some form of knowledge of 1 degree for every 69 miles, could you put that into the formula and get a derivation without having a 90? Or do you have to have it as QE said?
So it's 60 times 360, whatever that is. Can't do it in top of my head quick. Minus 360 times 60, multiplied by the cosine of the distance times. And the reason I know this decimal is because I bothered to think about it this afternoon. So to express this in nautical miles, it's 0.0166 is the decimal. I didn't.
So you can still do it.
Theoretically, if you were trying to express nautical miles as circumferential distance, yes, where circumferential distance of nautical miles would be 60 nautical miles times 2. Well, 60 times 360 someone. That's what you substitute 39594. So yeah, you can change
21,600.
Yeah, so that minus that times the cosine of the distance times, yeah, that's what that equals. So, but the decimal would be 0.0166. Because I bothered to work it out this afternoon.
Okay, so this definitely could be put into practical application, but you first got to accept a flat Earth principle.
No, not in the slightest. It had no practical application because there is no Earth curvature to mitigate for. You can express the units as kilometers, miles, or nautical miles when you talk about your travel across this circumferential distance, which is a straight line distance that you've then presupposed be traversing a circle, which you've, as previously stated, is expressed as a great circle route
Great
on a
circle.
ball. Yeah. So none of that is there in reality. But if you wanted to describe how you've travelled on a ball for that distance and what that would mean in terms of how far you are now below your feet from where you started from with respect to a flat plane, that's what this will give you. Just the same as
that does make my next question make sense then, because I was going to, based on that, I was going to ask the next question, which is, could this as a future presentation be made more lengthy with a juxtaposition between this and a resolution loss calculation, bearing in mind that one already exists in the form of the Earth curve calculator, it's just not labelled as such?
Well,
No.
I was going to bring that up, Nathan. Sorry,
He's already said no.
well, what I was going to say about it is, according to the Earth curve calculator, that a 6-foot object will disappear from view at 3 miles away. And the same is true for the angular size of a 6-foot object. They will disappear across a horizontal plane at 3 miles away, based on the average angular resolution limit of the human eye being 0.02 degrees. It'll reach 0.02 degrees at 3 miles away, a 6-foot object. So there must be some connection. Like, I mean, obviously there's a connection, but
Because of you laying it out rather than me, I figured out why the answer is no in that meantime. So because that's calculating for drop and hidden as opposed to a circumferential distance. Right, Adam?
Oh, this is maths. And as I critiqued George, his maths wasn't describing what he was claiming very well. Hence my reason to try and refine it and make it more accurate. I've made it more accurate, but it only describes geometric drop based on traversement of the circumference. That's what it describes, and where that point of traversement will then intersect the radial value to be expressed as the term called drop. That has got nothing whatsoever to using your eyes and looking out across the ocean. Yeah, it can't be done the same. And even if, and this is the quiet thing, I thought, oh, because I got my numbers backwards, Nathan. I thought 0.0145 in miles. What about nautical miles? Does it get anywhere near 0.0122, which is, I assume, the number you're heading towards with regards to Rayleigh criterion and optical dissolution for the eye, which is why I did that number. No, it went the other bloody way, because like I said, I got my numbers the wrong way around. But, and that's the point, even if it did, right, that would be correlation. Because,
yes.
And something they may have used for subdiffuse, but in no way are the two descriptors mathematically linked, because one's due to the optical cone and one's due to the rate of change of slope.
Slope, exactly. You got it. You're in a category error almost, right?
Right. Yeah, because it's 1.2 times the square root of the observer's height in feet.
No.
Go ahead, Adam. Explain it.
No. When I say that, I mean to compare to resolution loss.
Yeah, no, that's where there is correlation. 1.2 times the square root of the observer's height.
Yeah, that's what I'm saying. I'm saying
equals
1.2 times the square root of the observer's height in feet would compare to Brian's description if you're going to juxtapose it with resolution loss, as opposed to this, which just gives you the circumferential distance that you're trying to express at this point at 90 degrees.
No.
No.
Let me explain what I thought you were saying. I thought you were linking 1.22 times the wavelength of light divided by the aperture size. So that
No. I'm linking the maths for curve at 1.2 times the square root of the observer's height in feet to a juxtaposition with resolution loss, which this is not.
No, exactly. And the numbers don't match, unlike the distance to the horizon where they do match with regards to resolution.
Yes, that's exactly what I'm saying. Originally, I was saying, could you compare effectively where you say, no, doesn't compare to 1.2 times the square root of the observer's height in feet. That's what would be contrasted with resolution loss as opposed to this.
Yeah, there's no over 6R in this at all as well, which was partly what they'd invoke, Brian. Off you go. But yeah, this is just 6 of 6R, a descriptor of geometry. That's all this does, is describe geometry. It's only when you, and this is why I made the distinguish, it's only when you put that R value in to reify it in some way that it's anything other than just a lovely, beautiful, correct derivation. Yeah. When you put the numbers in, you're the one that reify it to make it Earth curve. The point of disagreement is that then the numbers it produces won't match reality.
Right, because 8 inches per mile squared compares better to the resolution loss we actually experience.
Well, it may well do. It's probably right. Yeah. Or there's more leeway. Yeah.
So George's Hanachuk, the late, may he rest in peace, George, his conclusion was, his overall conclusion from 8 inches per mile squared was that you will get less than 1% error over 1,400 miles. Is that correct, Adam?
I was going to say we can check that now, can't we?
I haven't checked it. I would probably, my gut reaction there is no, it'll be more than that. But if you're going to be that geeky like George is, then maybe. But what I would suggest is you've got to realize what that means.
Okay.
Yeah. So so less than 1% over error over how much?
1,400 miles.
1,400 miles. So let's just use 8 inches per mile. So 1,400 times 1,400 times 8 equals, divided by 12 equals, divided by 100 equals. That's not good, is it? Just
That's
check
not
that.
good. We can't see what you're doing.
1,400 times.
Hold on. Can you do this with a whiteboard while shaving, please?
Right, 1,400 times 1,400 times 8 inches is 15,680,000 inches. So divide that by 12. So 1,400 miles. Remember that on a ball. 1.3 million feet. That turns out to be. So divide that by 100. So we've got 1% as our margin of error. Still 13,000 feet. So I agree. If you go over 1,400 miles and you're happy to be 13,066.666666666 recurring feet out, George, then that's my point I'm making. I don't want to be 13,006 out. I want to be exact. Now,
that's not a
my
problem.
claim.
Yeah.
No, but do you understand that this is what ballers do?
What's that in miles?
Use a
I'm
bit
just
of,
trying to rack out. Sorry, can you just do the
lies.
conversion? Sorry, just 1 second. What's the conversion into miles? I'm not very good at converting these things.
Well, 13,000 feet, so that's like 2.5 miles.
Over
2.5 miles out at 1,400.
Yes.
Miles.
Yes.
Right. So if you're happy with that level of inaccuracy, you're 1%, then off you go.
No, that's if it's 1%. We haven't actually compared and contrasted and done the maths to compare it at 1,400 yet, have we? I don't know if you're going to do that.
I'd have to sit with a spreadsheet and do it, and it's
Fair enough.
Well, you'd have to start.
The point, it doesn't matter. That was George's admission that it's 1% out of 1,400. Right. If it's 1% out, you're 2.5 miles out. You understand? That's just nonsense. If you're going to be holding anything to account, like I say, if you're going to presuppose, be accurate.
Yes. But it is kind of minor when you're talking about 1,400 miles. But Adam he's got this precision and accuracy to him. You got to love him for that. But okay.
Why shouldn't he be? They're making geometric claims. In terms of their maths, it's perfect. Do you know what I mean by that, Adam, when I say their maths is perfect? That for the actual purposes of being
Hold on, Brian.
100% accurate.
Hold on a second, Brian. It's a bit impractical. That was just an extravagant example, 1,400 miles. Are you saying 1,400 miles? I don't think so.
It doesn't, right. Okay, let me put it a different one, and I want to hand over to Brian.
Okay.
He's the guy that this is useful for, because he argues with these idiots. Right? Now, if we think about some of the ranty stuff, shark boat, all those things, or if we look at looking at Toronto across the lake, and the way we're going to judge these things is the fact you can only see from the 5th floor upwards. Right now, if suddenly that variance between 8 inches per mile and my formula is 40 foot over 30 miles, then we're not talking about 2 or 3 floors. Well, this is the evidence that they cite to you. Look, we're only at the 5th floor. Yeah, or
feed him back, QE. QE, you feed him back.
Yeah, and so I'll just read out. This is the stuff and the detail that is thrown at, I think, in Discord rooms. This is what ballers bring to the table still, and that's certainly what Brian deals with. So hopefully Brian will support me in that you've got something accurate that isn't out by 4 floors when you're looking at a block of flats and you decided how many floors you can see. Actually, if you've got 3 or 4 more floors that should be visible but that aren't, even by their geometry, and or vice versa, that accuracy really cocks up their argument.
Let's try my other point because it got ruined by Brian. Unless Brian wants to go first. Did you want to add something, Brian?
I'm just got some accuracy in a moment, but I can go after you, Nathan.
I was going to say, what I was trying to get across earlier is when they say things like maths doesn't lie or the maths is perfect, in terms of Adam's yearning for accuracy in this regard, don't see it as unjustified. When you're going to the maths of their geometry and presupposition, there's no reason why it shouldn't be, in terms of the maths, 100% without flaw. There's no reason why it shouldn't be. Correct, Adam?
Yeah, the Blackpool Swan's a great example when we took Roofy apart. So when I did the spreadsheets to show Roofy that actually, if you're going to portray that mountain range, actually that peak's this far away, this peak's this far away, move it down by these numbers. And when I did that, you couldn't see half the peaks that they're seeing. Yeah, and they're claiming. And that's why I'm saying about being accurate. It's not me that's invoking that the earth is curving, it's them. And if they insist on doing that, then there are implications. If you're going to make those, yeah, and if those implications are there, then let's put them accurate before we analyze them. Yeah, and 8 inches per mile does them a favor, guys. Yeah, it does them a favor. A couple of floors if you're looking at a tower block across Toronto Lake, yeah, whatever it's called. Yeah? It's there. It's a bonus for them. That is my point. And there's a reason they don't want it. And there's a reason that these same numbers, actually, when the geeks get involved, Walt Bislin, yeah, and Metabunk, there's a reason their numbers match mine. Because it's their claim. They've bothered to make sure their claim is right geometrically. And that's all this is doing, holding them geometric.
And there's more. There's more to it. Because further to that, if you look at Walter Bislin or Metabunk, there's a reason why, when using the more accurate methodology of actually deriving this mathematically from their presupposition, they have to infer refraction immediately, undoing their own original claim. Because the original claim, in the most simplistic terms, is the geometry of the hill that's going to block your view. Well, as soon as you put that into the actual maths of Earth curve with a presupposed radius that will back engineer into the stars, it doesn't work. You've immediately got to make mitigations for the fact it doesn't work. Right, Adam?
Nothing will. And immediate. And this is why it's useful for Brian. Because the first thing they've got to do is deny their geometry. That whatever they're seeing, it isn't where it is. When you're given these numbers.
Precisely. And you go, these numbers, your hand ain't where it's supposed to be. fails immediately. Suddenly you've got to take yourself into a la-la land where what you're seeing isn't where it really is because it doesn't match with the maths of the geometry of Earth curve getting in the way. Therefore, everything's got to be always refracted without exception. Therefore, your hand isn't in front of your face when you're looking at it.
Well, the accuracy I would add here would be that the thing they don't like, right? It'll be the most accurate, but it'll be the thing they hate. Is that you must start with where their radius came from. Where did they get their circumference, their radius, their diameter? Came from flat Earth elevation angles to Polaris, which when laid out gives you a straight line of altogether, if you want to use what they turned into a circumference, a straight line of 21,600 nautical miles. When you turn that back into circumference in statute miles, you get a 24,857.28 statute mile circumference to their globe, and that is correct because they have to adhere to the original measurements, right? The original measurements were degree measurements and nautical mile measurements, right? Obviously, it started off with statute mile to find out how many statute miles was in 1 degree of optical drop to Polaris. Okay, so technically they started with statute miles. So they found out there was 69.04 statute miles horizontal. That's one big horizontal, right? Will give, once you're north of the equator, if you move north or move south, will give you 1 degree of angular change to Polaris. That was the beginning point. They divide that by 60, which gives them a ratio between the statute and nautical of 1.1508. And from then on, they could just use nautical miles, which is just minutes of degree transposed down onto the surface of Earth to create, the latitude and longitude grid. And that's what they hijacked, and that's what they turned into a globe. And that gives them a globe of 24,857.28 statute miles. That is their globe. And
Yes.
for
And I want you
absolute
to-
accuracy, that would be the best.
I want you to be reiterating that every day from now on, Brian. I don't mean in the most literal sense, but you know what I'm driving at. Because that is the key to every globe claim ever. I was about to say at the end of it, well, that's orbits as well, isn't it? It's the same principle. To back engineer an orbit into the maths of the movement of the stars, you start by transposing the flat plane measurement of a radial value at the inferred equatorial minimum into a globe. Then it works. Why does it work? Because it has to back engineer into those movements of those stars when measured on a flat plane. Ergo, every globe claim starts with the genesis of a flat Earth measurement. Without exception, there is always a route back because of what Brian has just said. Now, in the last 6 months, when I was iterating that to the panel, it gets shut down in favour of the point that was being made that was globe-centric, globe-biased. So in this instance, this is a perfect example. Everything that Adam's done within his workings of explanation for why 8 inches per mile squared isn't comparable to his derivation when using trig by minusing R1 from R2, or however he labelled it with his right angle triangle. And he is more accurate, and it is exactly how they do it in the Earth curve maths. But that's very much heliocentric biased in terms of how they defend and argue their globe and how we should take it apart, or more accurately, how they should be claiming it. What Brian's done is taken it to a place of where do we minus D1 R1 from R2, or however, I've forgotten how he labelled it, but the radius value for the second triangle. Where do we get the radius value from to start that process in presupposition, where Adam says if you're going to beg the question, at least be accurate about it. Well, at least know your origins for the radial value you're going to beg the question with. Not a case of any evidence of the R value for a sphere. It is measured, it has to back engineer into the reality of the stars for mapping, and it is a flat Earth prerequisite. Once you know that, and I didn't, well, as much as I hate to concede to this, Brian, I'm sure you'll back me up in this. When you, prior to say 6 months ago where I was on this tip as well, you put this to the panel, not Globers, you'd be met with a stony silence because the chances are people hadn't quite realised the importance of what you just said, and then they'd move on. Yeah, good point, Brian. And also, the 8 inches per mile squared only works up to 1400. Do you know what I mean? The penny hadn't quite dropped for the significance of what you'd recognised at least 2 weeks before I did 6 months ago, right, Brian?
Yeah, I don't think the importance of it was getting through, because there's more to it. There's actually levels to it more than that, and I want to get into those levels. If you allow me for a moment.
Right, Brian. Before you
Yes.
do, I'd like to ask QE to move to slide 3.
Yes, sir.
And I'm just going to reiterate point 1 on that, which is to underline what Nathan said, and then I'll answer you. Exactly that, Nathan. Look at the statements I made with regards to how I could move forwards to develop this. Making a curve calculator. Point 1. Yeah. Assume the Earth is a ball of radius 6371 kilometers. And 6 years ago, I bothered to put 5 exclamation marks after that point. Yeah, that's fundamentally the key to making an Earth curve calculator. Assume the Earth is a ball. Now we get to what Brian's saying. How the hell can we assume that? Yeah, and they assume it from flat Earth measurements. Yeah, of Polaris. I'm done, Brian. Over to you, mate.
Thanks, Adam. Yeah, well, the power. This is something that QE will recognise because he hit onto it, and I forgot he had hit onto it before I even made a video about it. I actually had forgot about it. And he just recently, he was presenting something privately with me and Adam and others, and I remembered. Oh, I remember this, and that's where it was in my head from. If you look at the globe and how they reference Polaris, they reference a load of parallel light rays coming down, hitting their globe from one equator, so one side of the equator, over the arc and down to the other, and all of their angles, right, are all tangent planes, right, where the light from Polaris in the straight line hits it. But the problem with that is this: that means that they're claiming that when you're in a boat, right, and you're looking at Polaris and you reference the horizon, that you're actually referencing the geometric globe edge that is only in their maths, because that's only mathematical. You're not. What they have to claim all the time is that when you're looking at the horizon, that you're looking at a consistently refracted position that's refracted at different rates from hour to hour, day to day, right? How would you get your latitude if the horizon is not geometric, if you're claiming to be on a globe with Polaris and a marine, in specific, a marine sextant? How would you know your latitude? But do you see the point here, Nathan?
You just asked Rufy. I'll ask him on your behalf.
See the point? No, this is for you.
No, I'm asking Rufy. I don't know. I just have to ask. How's that geometric horizon working out for you, Rufy? Good?
That's the point, Brian, isn't it? That's the point, and that's what we've presented tonight. The way, if you're going to create a tangent on the top of a ball to do this thing, then you've got to have, as Brian sarcastically said, consistent refraction. Now, that refraction, as the ballers will try to present, is not commensurate with dip angle. It's commensurate with just the geometry. Now, when we get a black swan day, you get the claim that we've got infinite over 6R. The way they'll try and attack Brian with the majority of stuff, they do 7 over 6R. Yeah, but the way you do a dip is with 6 over 6. None of these things, when they try to invoke the ball, match any of them ever. They're just approximations to it, just like 8 inches per mile. Yeah, because as we said, the ironic thing, you said it earlier, is this anything to do with Rayleigh? They try, don't they? They try to merge all of these things. And at this point, they're now trying to ignore their geometry and give refraction as an explanation as to why the geometry doesn't match.
Well,
working out, Rufy.
Sorry, thought you were finished.
I'll just reiterate your point, Brian, to get you back on track. Brian's saying there's no way of referencing a geometric horizon in terms of how you actually establish the horizontal plane. When you get to the point of tangency with a whole load of tangent planes moving around the 90 degree that Adam had up earlier, none of them have got a referenceable horizon. Each and every one of those tangent planes moving around from a Polaris-centric description in orthographic view, has no referenceable horizon. Their horizon's geometric. Their horizon isn't conducive with dip correction. Again, Brian and I 2 years ago were at loggerheads about this because I didn't recognise the significance of it. It's very important. They don't have a conducive horizon to perform this functionality. How's your geometric horizon working out for you there, Rufy? Good? Good? Nah, don't think so.
Well, my point is that here is not even about dip correction because it takes dip correction out of it when it comes to Polaris. My point here is that when you're out on, okay, Nathan, will you role play with me for a second? When you're out on a boat and you're north of the equator line and you're looking towards Polaris, you can take your angle to Polaris via the horizon. And all you will have to do is subtract your height of eye to get your correct latitude. Is that or is that not true?
That's absolutely correct.
Yeah. Well, that is the horizon that they're claiming is constantly refracted. Yet, when they are trying to reference their globe in relation to Polaris, that can't be a refracted horizon. That has to be their geometric. Kiwi is laughing. He knows all about it.
because when the black swan was born that day, its curly-haired brother was right behind it, and Brian is all over it. That's exactly what I thought. That was the death of the BALLTARD spinning space monkey. That's Brian. Brian's he's all over it. Yeah.
Yes, exactly.
Yep.
Because exactly, Kiwi. Because when you look at the horizon to get your latitude via Polaris with a marine sextant, it has to be specific because they'll try and switch to a bubble sextant and an artificial horizon and all this other rubbish. When you're dealing with a marine sextant and getting your latitude, right, north of the equator with Polaris, the horizon you see is the horizon you will use, and you will get your correct latitude. They can't do that because that, in their paradigm, is not their geometric horizon. Their geometric horizon is somewhere below surface level mathematically. And that's the geometric horizon is the one they must reference for their latitude, for them to have a correct latitude. And they can't reference it.
They can't.
Showing that the whole thing is a fraud.
Yep.
Yeah. Where did the black swan?
They can't reference it. It doesn't work.
Where did the black swan? Hold up. Where did the black swan touch you?
Exactly.
I can show you on the dolly.
And it almost seems ironic that my frustration was at them all reiterating refraction for 2 years while you were laughing about it. Because that's the death nail, isn't it? And
yes.
They were sealing their own fate for 2 years while they barked refraction, and they
yes.
didn't even know it.
Yes, sir.
My gloating at people like Rufy, gloating over the fact that he spent 2 years barking refraction at us, not realizing that the more times they barked it, more nails they put in their own coffin because there was no way back when we got to this point.
Yes, sir.
So, to bring it to the black swan on the 1.22 times the square root, that is equivalent to 8 inches. What I would say to you is it's probably, if you just take the first mile, it's probably nearer 7.8 inches. Yeah? 0.2 of an inch. Now, that's not a lot, and optically it's not discernible. Yeah, as I say, everything's in their favor, isn't it? Once again, I want to take another little look into a man. If I say I want to take 0.2 of an inch away from you, you're not going to be happy about it. Yeah, and they shouldn't.
I'm stopping the double entendres. You're not allowed to be the QE. Stop it.
Point is, it's theft, optical theft. That's what's going off. It's all there in little increments, but they're all hidden there so that supposed curvature can be matched closer to reality, which doesn't account for curvature.
Superchat.
Oh, Flatsy legend.
I just got up and you had to say that.
Yep.
Superchat, super fluid, super mullet, supercomputer. Go.
It's Sasha. He said, C is curved, but it's straight. Triangle is formed with a laughing face.
Thanks, Sasha. Is that it?
Yeah, that was painful. I waited for a long time to shout that one out. Sorry, Sasha.
Sometimes 0.2 of an inch can make all the difference.
I ain't gonna
It
say.
does. Seriously though,
Flatsy, just get right in there, Flatsy. Super chat supersede everything.
Yeah.
when you're told about, oh no, you can't see the bottom of platform A and B, and that's the argumentation that's presented to you, and actually that 0.2 of an inch is even more significant. Yeah. Like I said, when you're dealing with idiots that want to presuppose, you may as well destroy them mathematically. But fundamentally, you see, they're being held to their geometry. And this is what Brian's doing with his bit. The second they're held to their geometry, they then move to say, refraction. But the way in which they navigate is to have something that they can do a dip angle to give them a surety that moves, but doesn't move, depending on what it needs to do to give them accuracy of navigation, or to move to allow the fact that it's curved appears flat. So you've got a juxtaposition. It's that Orwellian paradox. And this is the point, that with dip angles and the use of the horizon geometrically, as Rufy shows with his comparisons, that's their claim. Now, you can't have that claim moving every day, can you? As they say it does with the Black Swan, to give you the random day where you can see past this.
If you want to, as an audience member, understand this in a visual way, the dip correction, as Brian says often, is to the surface level. That's what you're doing your height of eye correction to. You're correcting to surface level. Okay, now go to Metabunk and have a look at the way the orthographic view of the curved maths is laid out, with a ball dangling below surface level. The geometric horizon is also below surface level, and what you're using dip correction for is to correct your height of eye to surface level, or the horizontal plane of reference that you're using to measure this angle with. Ergo, you can't use the geometric horizon. It never ever is useful as a correction tool to make you more accurate with something that's set in stone, surface level. That's what you're correcting to. They haven't got one. They've got a geometric horizon below surface level. It's useless to them.
Exactly, Nathan. Sorry, Adam.
Just to follow that, thank you, Nate. They're using that dip and the known geometric rate of dip based on R to realign through the sextant to that known dip, to bring it back up to create a tangent on the top of the ball. That's the theory. Then supplementary to that, they make the statement that known dip can move, and in actual fact is at least 7/6 R on every single day, and sometimes, Rufy, can be infinite over 6 R, mate, can't it? How the hell do you find to something that varies that much? Yeah.
So what use is it?
Yeah, it's not a point of reference, is it?
No,
Can
it
they
can't.
take this into consideration?
No, it can't be. Yeah, we all took it into consideration some years ago. We just everything just come together. It's come together before.
No, not us.
What the hell is he moaning about through me?
Didn't they realize this? I'm not saying us. I'm saying, didn't they realize this?
They can't tie their
And they
shoes
just
without a
went with
fleet of slobber nurses.
Well, let's answer him. Yes, they did. And in the same way, if you rewind history for any protagonist that's inserted some of these extra layers to the geometric claim, you'll see that there's always an individual that's recognised this and mitigated for this. Take Walter Bislin as a prime example. In terms of visual representations, We have critiqued that it's in orthographic view. He has come along and mitigated for that by putting a perspective view, bastardization of orthographic view, in his calculator, so that some numpty can come along and go, look, in this 3D rendering, it's got perspective in it. No, it hasn't. He's offered that up as a mitigation for what essentially we have critiqued. And that is presumably how these things, globe earth lies, get refined over time. Someone like us comes along and says, well, this makes it make no sense. You can rewind that all the way back to, what's the guy who had an objection about the sizes of the stars? Not Kepler, it's...
Brahe.
Brahe. Right. So you can take it from either side. An objection is an objection that's just waiting to be turned into an explanation, isn't it? Well, they'd have to be enormous, those lights in the sky, for this scale to work. What's that you say? They would have to be enormous. Well, then they would have to be enormous.
Then they are.
They? So then they are. Exactly. Suddenly the objection turns into the explanation. Well, they would have to be enormous. Just change your tone slightly. Well, they'd have to be enormous. Suddenly it's an explanation rather than an objection. And this is no different. Well, there's no perspective in it. Well, let's give you some perspective then. It's not that the maths is suddenly going to be based on angular size reduction. We'll just give you a 3D rendering if that's what you're moaning about. You're moaning there's no perspective in it. What about if I just slap it up together as a perspective view, even though the maths still works in orthographic? They're just layering on. I used to call it filling in the cracks of heliocentric bullshit. See a crack in the pavement and go, we need to slap a big fat layer over that, quick, sharp.
And they would have to be at a certain distance. So then they are.
But there does reach a point where cracks can't withstand the weight of the filler on top of them, and this is that, right? Because there's a certain point where you can't get around problem that comes. This is a brick wall. How's that geometric horizon working out for you, Rufy? Seems maybe to the audience's ears, if they're uninitiated, like a throwaway comment, like I'm just joking about Rufy. No, there are very severe implications that Rufy's well aware of. So I shouldn't laugh. He buried himself and nailed himself into a coffin for 2 years, and I shouldn't laugh when I'm trying to stress the seriousness.
Yeah. He's still laughing. Look at him.
I'm sorry, hold on. I've got a serious point.
Take a break. Listen, take a break.
Oh, dear.
Yeah, you need to gather yourself. All right, listen. I've had this up on screen. Hold up a second. I've had Adam's presentation up on screen. I've been giving you the American measurements for your Earth curve calculator. Plus, I've been jostling back and forth to the metric, and I've had these up the whole time. Now, before I take this off, I just want to make sure that you know where this presentation come from. Okay? It came from the Adam Macon.
Just if we're unsure, that would be the Adam Macon presented this.
There you go. Carry on.
Excellent, Adam.
Because I can't stop laughing. Brian, please can you reiterate the importance of this? Because I can't.
Yeah, I will. I'll point out the importance of this. When they claim a tangent plane that they're placing underneath their boat, what the boaters don't realize is that tangent plane is stretching all the way to wherever the horizon is, no matter how far away it is stretching to that point. Because, and actually further beyond, right? But they think it's just a little tiny line that they place underneath their boat because they don't realize, right? The proof of that is this. When, as I earlier on, Nathan, spoke with you, and I used you to ask you to role play with me, I pointed out that when you use the actual horizon, one north of the equator with a marine sextant, to get your latitude via Polaris, you will get your correct latitude via the actual horizon we see every day, all day. That is what you will use. That means, right, because in their paradigm, that's claimed to be a consistently refracted position, which means that is not their geometric horizon, which means that they're getting their correct latitude off of what they're claiming to be some class of a 7 over and greater than 7 over 6 or refracted horizon. So how would, if you then place their latitude and longitude grid around their globe, which is where the globe came from, what they're doing then is they're getting their correct latitude off a horizontal. That's actually what they're doing. They're getting the correct latitude off a horizontal plane and not referencing the globe they're claiming to be on. How can you not reference the surface of the object you're claiming, the 3D shape you're claiming to stand on for your correct latitude? How can you not be referencing that, but referencing a completely different horizontal plane to get your correct latitude and still claim to be on a globe? How can you do that?
They can't. So they do it from a. Sorry, I was going to say, well, they don't. They do it from a single point on the dingleberry, which is what you're describing as tangent planes. But at some point, for this to actually function correctly, they have to transpose it inside the globe. So the celestial sphere is sometimes described by them as a spherical coordinate system because the lines have been transposed back down onto the globe. So you can infer that it's a spherical coordinate system, whereas in reality, that coordinate system only actually functions inside the globe if you're going to infer a globe at all, because it's redundant. It's not even redundant. It's surplus to requirements because you... Adam?
Doesn't function ever inside the globe. What you do is take those same flat Earth measurements to the center of the globe and then project them. Yeah, no, it doesn't. My objection was it functioned. No, it doesn't. Never functions there. It never has. Never will. Can't. It's just a way of sorry. It's just that.
Fair enough. I'll just incorporate that as well. When you say it doesn't work, it's because the original part of my description to get us inside the ball, which is how they diagrammatically represent it, is on the tangent planes Brian described moving around a sphere. That bit never works. That cannot work. The only place it does work is if you would start measuring the angle inside the sphere, and it will match up with the celestial sphere on the equatorial plane. This is where I was going to segue back to Brian, because when Brian says you can't have this little tiny tangent plane functionally working, well, no. What actually functionally works is the infinite expanse of the equatorial plane extending beyond the equatorial minimum of Polaris, because that is how it functionally operates when you're measuring angles off a flat plane. That's the only way it will work. To back engineer it onto a globe, you've got to have those lines transposed onto a globe. And back to Adam, it just doesn't work on the surface of a sphere Earth. And it isn't functionally utilizing the surface of a sphere Earth. It can't.
I think you slightly missed. I won't say you missed the point, because what you're saying is relevant anyway, right? I don't mean it that way. I'm not saying that what you're saying is wrong. My point being is that they're getting their correct latitude off a tangent.
Yeah, not off the geometric horizon that's below that inferred surface level as the tangent. Now, I do understand your point. Tangent they draw out doesn't have a geometric horizon. That's where they're actually deriving this angle to get their latitude. Their tangent plane only has a single point that touches the surface of Earth. Ergo, it isn't the geometric horizon, because from that single point, with a tangent plane drawn out into space, effectively, isn't a geometric point on the surface of a curved Earth that's below the surface level. And that tangent plane, if you want to say that's the point they're getting their angle from, is the same surface level in the curved maths, from a single tangent point extending out 90 degrees into space. Make sense? Sorry, that was my Skype line open.
I think.
Yeah, but wait a second. Wait a
missing.
second, Brian. Before you smash him, that's fantasy, because as soon as you say tangent plane, there is no tangent planes. That's begging the question fallacy number one. And please show us the tangent mirror on the sextant. I want to see.
There isn't one. Sorry, Brian. I've got to do this now. I'm sorry, Brian, because QE's piped up. That's correct, but I'm just trying to explain it, how they diagrammatically depict it. So in my head, I've got two things to compare and contrast with the non-existence of this and the fantasies of tangent planes. You're correct. I'm just giving you Dingleberry and Globerger. That's it. I'm just giving you their explanation for it if it were to be presented. I realise.
Okay, so if I allow the creation of the tangent plane, okay, that's what they want you to do. Okay, Brian's point of contention is how you establish that tangent plane at this point. Forget taking it to the center and mathematical nonsense after that, projecting it out back out from the center where you never were. We're on about just establishing that tangent plane. How do we do it? How do we do it in terms of creating a level with the surface? We use the horizon. They claim to do the same. Now, when we
hold on, no, they
demonstrate-
don't. Hold on, there's a point of detail that they do here that I'm going to drop in. Because it came up by QE earlier, and I want to reiterate it to tie it back into the subject. Why don't they want to use a Marinus sextant? What do they do to mitigate for this when they're inevitably dragged onto this path by us? They want to use a plumb bob. They want it. Why are they being rumpus? Stop making the most important bit of how they
Oh, I thought you were
deviate
asking
from
a
this.
question. Sorry.
I know. Well, it was rhetorical. How did they? Okay, well, it wasn't. You can answer it then. Why don't they want to use a Marinus sextant, Brian?
Because it has to reference the horizon.
They reference the horizontal plane. So where did they get it from when Adam says, well, they can't get it? Well, they get it from 90 to a plumb or 90 to zenith. They can infer that there's a tangent plane, but that isn't how you would establish it with a horizon and a geometric horizon in more important terms when we're talking black swan. It's destroyed and refractions nailed them in the coffin that won't allow them to then reference it. So they haven't got a geometric horizon to reference, but they're referencing the horizon. How can they mitigate for that? Drop a plumb line and get 90 to it. Draw out a flat plane with the 90 to it. And then deny 90 quickly.
The problem with them is that just give me one more try at this, Adam. The problem with this whole thing, and why I'm bringing up latitude, is this: they want to consistently talk about bringing a line from the horizon up to the eye line, and that being their tangent. No, their tangent is underneath their boat, and that tangent line goes from underneath their boat in a straight line out to the horizon. So when QE asks, where is the tangent mirror on the sextant? The tangent mirror on their sextants, in reality is called a horizon mirror, because they're actually referencing their tangent when they're referencing the horizon. The line they bring up to their eyes, or claim to bring up to the eyes, is not the tangent.
That's so important. Okay, Brian's point there. If you're on a ball,
no.
I said no.
Brian's
how they,
point is
let me drop
important.
it in. I know it's important, Adam, because that's not how they functionally do it in debate. They do it by blagging that they're getting the zenith. And I go, what, from the zenith mirror?
No, it's not linked. No, we're on about establishing a level on a boat. Okay, now they claim they're using the horizon to level. That's Brian's point. I don't want to steal it off you, Brian. Forget the zenith. They'll try and mitigate that thing which you can't do on a boat because boats rock, so you can't use a plumb bob. But they'll always try and bring it back to that to try and establish a level elsewhere. Focus on what they're trying to establish their level through and from on a boat. Can't use a plumb bob.
Thank you. I just wanted to acknowledge, because that is where they would try and mitigate. And if I don't drop it in, someone sees it as an opportunity to drop it in the comments. Go ahead, Brian. Now you may continue. Now it's been acknowledged.
Yeah. Oh well, it doesn't matter if they say zenith. If they get that far and start saying a zenith angle, that means nothing. A zenith angle is just the opposite from an elevation angle. It's read from the vertical to the horizontal. An elevation angle is read from the horizontal to the vertical. It's exactly the same thing. If you know what I mean. The angle itself, it still requires a horizontal and a vertical. So when they say zenith angle, they think they're avoiding something. They're not. See, the problem is that they think tangent is that.
Let me define it. I've actually got a specific definition because somebody ended up challenging. I think it was Blue Marble Science, the photosynthetic retard. So I went and dug up one of my citations because he was like, no, we do it with zenith angle specifically. We don't need the surface of Earth. So I went and dug this up. I think this is actually from Wiki. The solar zenith angle is an angle between the sun's rays and the vertical direction. It is closely related to the solar altitude angle, which is the angle between the sun's rays and a horizontal plane.
Yes.
Since these two angles are complementary,
yes,
the cosine of either one equals sine of the other.
Yes. That's what Brian was saying. Yeah, it's the flip side. It's the same. It's the flip side of the same coin, is what he was saying. What Brian was saying.
Yeah, but I wanted to define it by wiki just to and drop Blue Marble the Dumbo in.
Mr. Gumby football field. Go ahead,
Well,
Brian.
it's worse than that.
When we take an
Come on, Brian.
elevation angle.
Hold on, Adam. Go ahead, Brian.
Hold on, Adam.
To your
Leave Adam go and I'll say it then. I've a...
All right,
it's
go
not a
ahead,
separate
Adam.
point.
Evening.
Go ahead, Adam.
Thank you. When we take an elevation angle, the angle is referenced to the right angle from the observer, i.e. zenith, and the flat plane. The angle reference is to the x-axis. And in this understanding, that would be the flat plane. When we take a zenith angle, we reference the plumb bob, yeah, which is the way we that calibrate it. But it's still referenced to the x and the y-axis. The x-axis being the flat plane, and the y-axis being the reference angle now when we take the co-angle. They're the same thing, reference to the same flat plane. How we set the device up, whether we use a plumb bob so that we're getting our calibration from down, knowing that when we hit down, when we hit a perpendicular to that, we've got the x-axis, yeah, all the way across the surface we're going to navigate on. It's kind of irrelevant. As Brian says, yeah, we're referencing the same thing. It's just a different way of describing it.
I've got to now drop in where they go from here before Brian gets. He's going to hate me. Where do they go from here? What would a baller do at this point? So this is my favourite moment in debate at the moment, when they tell you it's not the surface of the Earth. What's that you say?
I knew it.
Very
I knew
specific.
it.
Very specific surface that we're navigating and detailing how we navigate and how we measure. Now that we're absolutely unequivocally measuring it flat, it's not the surface of Earth. I've had two so far. I've had Brenda do it and a guy in 24/7 Discord do it. He came up and I'll publish this shortly. I've edited it today. Guy came along and told us a story about travelling to Lapland. Yeah? And all of his story is about how they're going to get more accurate elevation angle measurements to Polaris to give them the degree differences in actual travelled measured distances and compare it to an elevation angle measurement to Polaris. This is the crux of his story. When traversing Earth and surveying Earth and seeing how it all works, and that's the purpose of his story, until we point out that that elevation angle measurement is going to require a flat Earth. And it wasn't about the surface of Earth. And he said, I wish I'd started the story about navigating Earth and proving how spherical it is with my presupposition that elevation angle measurements are working with degrees of a circle. It's not about Earth. I wish I'd just started in Lapland. That was his answer. Suddenly, I wish I hadn't started my navigation story about how they're going to more accurately tell us Earth's a sphere with the journey of how they did it, because that was proving Earth's flat the whole time. And now you're pointing it out. I wish I hadn't told you.
Yeah, but what I'm saying
can I
there...
just go sideways, guys?
Brian's been in the queue for a while. I'm sure he's...
Brian, go, and then please let me go sideways, because Roofy's just been texted. Go, Brian.
Yeah, I won't take too long. When they say, Nathan, that they're not referencing the Earth, what they actually mean is they're not referencing the surface of a globe. That's what they actually are saying, isn't it?
Yep.
But besides that, my point being with latitude, and I don't know, I know QE's onto it. I'm pretty sure QE's well onto it. But my point being is that the tangent that they're going to have to claim will be underneath our boat, not at the eye line. And it will stretch all the way to the horizon. Now, that means they're getting the correct latitude every time off of a claimed tangent. How?
A flat plane.
Yeah, but you must look at the globe. The globe is constructed out of the latitude and longitude grid. The latitude spacings down along the longitude lines that intersect the longitude lines, right? If you look at that on a globe, right, that's the actual globe. It's not a 7 or greater than 7/6 globe. It's not a tangent plane. They if you look at how they work it out, they claim parallel light from Polaris. Now, it can destroy parallel light with the moon, but that's not the point. The point is that their claim of parallel light hitting the globe and them having tangent planes and getting an exact angle, right, to Polaris, right, is not referencing. And when they claim they use a tangent plane, they're getting their correct latitude off a tangent, not off the surface of their globe.
Right.
I think this is. I think you're missing it, Nathan. You personally.
No,
Right. Are you
not missing
saying
it at all.
on
That's why they
on
don't
a
want to use a
globe-
Mariner's sextant, because they're looking at a horizon, and their horizon is an Earth curve edge. Their tangent plane doesn't facilitate that. I do get it, Brian.
No. And that doesn't matter because they're not on a globe. So when they use a sextant to get their elevation angle to Polaris, they've derived it from a flat plane. So that angle is true. Now, when they then translate it, and this is Brian's point, I think, what they've done and these are the nuances I want you to specify on, Brian. In the northern hemisphere, that matches still.
Well, it means that they're not getting their correct latitude referencing their globe. Now, that means everyone gets the correct latitude. Everyone with a marine sextant north of the equator gets the correct latitude via Polaris, not referencing the surface of a globe. Now, you look at
with an
every
elevation
globe,
angle.
Yeah, but hang on. You look at every globe, and every globe will have the latitude and longitude grid on it. That is the exact way it's spaced on the globe. The only way for that to work would be if you were referencing the surface of the globe, but you're not referencing the globe to get your correct latitude.
You're using an
Everybody-
elevation angle measurement, which is only facilitated by means of a flat Earth and utilizing that flat Earth to measure plane of reference for the angle. Ergo, if you're talking about Polaris, all you're talking about is a giant area of equal elevation. Again, just a description of a flat plane and how it can functionally operate. If you try and make that work on the surface, tangent plane or otherwise, it will not. If you try and then reference that back to a geometric horizon, because to reference a flat tangent plane isn't the horizon that you're looking at, means they haven't got a geometric horizon to reference. It isn't the globe surface that's being utilized when they establish flat to give them an angle measurement for their latitude with Polaris. That's only possible on a flat Earth.
Go ahead, Adam.
Go on.
I think they're arguing at differences here. I'm hearing significant things Brian said.
Yeah.
And we're trying to establish something different. So probably at a point for another time. QE, I've sent you the link.
Uh-oh.
I just think this is interesting, guys, because like I said, Rufy's bothered to text me during this show. So I'll read you what he said. He's just sent me a link to Where's Wally video, which is, it's now 12 minutes old, this post, but it's actually critically appraising tonight's show. Now, I mean, first point, QE, you said to me, there's not enough at the Adam Meekins on the presentation. Clearly isn't, because the show is titled QE, Brian, Adam Nathan Comedy Show. And bigger Adam Meekin logos for the next presentation, which I'll make sure. But anyway, so he sent me that and he said, Nathan pulling all your chains, the couple of laughy faces beforehand, but probably you put them afterwards and you use a question mark or at least an exclamation. Anyway, so I said, want to join? We are still live. He said, join what? So I've sent him the link to the thing that he's just sent me a clip from. And he said, no, I'm good. Debate on gerunds. I bet he is. Isn't that what an interesting statement, ladies and gentlemen? So Rufy, after sending me a clip where he's laughing at what we're saying, given the opportunity to come in live to the thing that he thinks is brilliantly funny, he says, no, I won't bother. I'll address this on that well-known flat earth supporter channel, that science denier, Darren. Interesting how Glenn would cite that as his place of
I was really hopeful for a minute. Did you not answer my question? I specifically asked how that geometric horizon was working out for him. Did you not answer you?
Nothing, mate.
He'll let you know on challenge stuff.
That's right,
on,
Neil.
Neil.
Absolutely. Probably next Thursday.
Give Neil a minute. He's got to explain. That must make your blood boil, sir.
I said he'll let you know on his friendly German show. You know, he's got to go to a friendly.
Yeah, well, either way, the point, I've sent QE the link, and maybe we could play Where's Wally's thing that's instigated Ruhif. Yeah, remember how Roofy must be triggered tonight. He's killing him this, yeah? How is that geometric horizon working out? I've just showed him how to work it out, and it hurts. Because when we go into, like, nuances of ball argument, yeah, I hold him to it, and all he ever does is try to move away from his claim, his fixed geometry. And it's interesting, like I say, how triggered these guys must be, even though they pretend they're not listening. Yeah. Somebody's produced the video, and then Rufy's had to send it me whilst I'm still doing the video that he's produced the video about. Back on.
And they didn't put your name in it.
Sons of bitches put Brian first. I'm not. I tell you what, I reckon Neil's involved in this.
Right, I'm very good at picking up on subtlety, and as much as Adam and Brian have tried to be subtle about this, I've tried to paraphrase back and what I've considered to be the main point being illustrated in this particular example, that I suspect, because it was subtle from Adam and Brian, the penny hasn't fully dropped for me. Correct, lads? Something I'm not quite getting. I'm not paraphrasing it back to your satisfaction. I can tell.
Yeah.
So
yeah, it's not that your points are wrong. It's that your point is different from the point we're trying to relay. But as Adam said, we'll bring it up another time. It's something that we need to go through. We need to be able to explain it. QE knows what I'm talking about. We need to be able to explain it in a way, and maybe QE can do it, so it's just totally clear. Because the way I'm saying it is not coming across clear.
yeah, well, obviously, because I am attempting in my own special way to paraphrase it back in a way that lets you know I've understood, or the point that you're making has been understood in the nuance that you're making, and it isn't clearly, because you're like, you're not quite getting it. You've said that 3 times. Adam's then said, oh yeah, there's something subtle here that you're not quite getting, but then moved on to Rufif. Well, I'd rather know. So yeah, if there's something I'm not quite getting, then I represent a number of the audience also. Do you know what I mean? There's going to be other people who are in the same boat as me.
Give me a second then, right? Their globe was back engineered from flat Earth elevation angles to Polaris, which gave us the latitude and longitude grid, right? You know that. They just took the south ends of two corresponding, all the south ends, let's just say all the south ends of the longitude lines, and brought them around to meet like the north ends, right? So that gave them their globe. So that means their globe is restricted to being the exact size of the latitude and longitude grid as a globe. It can't be any bigger, can't be any smaller. It has to be almost exactly a 3.3959 radius.
Stop, Brian. This is brilliant. I'm only saying stop because at this point, remember, past south of the equator, nothing is confirmable. Carry on, Brian.
Yeah, I'm just talking about their globe. So that means
I'm talking about why and how they can construct it, because once they go south, everything is a presupposition. Now, this is why I asked you earlier, everything does match because they stretch things in the north, or they shrink things in the north, in certain places. This is part of the time bandits, so the north will fit base with magnetic declinations and a few other bits and bobs, it fits. And actually, the things that are referenceable, it does fit. Go south, how do you determine, your long and latitudes?
Yeah, they're screwed.
Yeah, exactly.
Yeah, sorry, Brian, they're screwed. And we're going to get into more into that with time bandits in late 2028. So, Brian, finish up.
Thank you. Yeah, my point in Nathan is this. The latitude and longitude grid is wrapped around the surface of their globe. That means the latitude for them, if you're getting a latitude at sea with a marine sextant north of the equator using Polaris, you must be referencing the surface of the globe, or else the globe does not exist. But you're not referencing the surface of the globe to get your correct latitude.
Okay, what I'm hearing is, if you're a globehead and you're claiming global and using the navigation system, you must reference the surface of your sphere. Therefore, you must be utilizing the geometric horizon. That's what you're saying.
Yeah, they are getting their correct latitude with a claimed refracted at whatever degree they want it, over 6 or 7 over or greater than 7 over 6 horizon. How can they be getting their correct latitude on a globe, well, referencing a claimed globe with an effective radius that's greater and often greater in multiple times the size of their actual globe, yet they're getting their correct latitude with the horizon that we see every day?
I think I've got the point. So the overcome after the fact is the Arwinian paradox, but the point your penny hadn't dropped on is they must be referencing their latitude and longitude grid with respect to a sphere surface and its geometry. Ergo, when they're drawing out a tangent plane, they're not using the surface to reference their navigation system. And when they say they're using a horizon, it's a massively refracted moving position that is in no way with respect to their geometric globe surface.
That's a married bachelor.
I'll make it easier. When you are on a boat north of the equator with a marine sextant and using Polaris in the nighttime to get your latitude, what they would have to claim is the angle that you take using the horizon, that you would have to add to that angle, because their geometric horizon, which is where their latitudes actually exist, is somewhere below surface level. So you wouldn't be just doing, it wouldn't be like a dip correction that would be off of a height of eye. They would have to add to that angle the amount that they need to add to bring that angle down to the surface of their globe where that latitude exists on their globe.
Right, and by add, you mean add in the refraction?
No, add degrees to the angle, because the refraction is claimed to always be there. They're claiming the horizon is always a consistently refracted position, and that's what they're getting their correct latitude off of. They'd have to add to the angle. So if you've got a 62-degree angle, it would have to become a 68-degree angle.
Hold on, Adam.
For their correction.
Hold on, Adam. Because refracted horizon, what? Married bachelors are in the corner blushing.
I know, but I know it's ridiculous, but it's important to this point.
Just so QE gets it right, I get the whole married bachelor thing, but it's just me to understand what the implications for them are. That's what Brian's trying to drill into me, I feel.
You mean after the married bachelor? Okay, go ahead.
Yeah, after the married bachelor of refracted horizon, Brian's trying to drill in the implications that have consequences for them and what they are. Yes, it's got a married bachelor in it.
I make it as simple as possible. Give me a second, Adam. Give me a second. In reality, your latitude is coming from a horizontal plane. Their latitude is the latitude. Let's say you get an angle of 40. If you get an angle of 45 degrees to Polaris.
The penny's finally dropped. They're getting their latitude from a horizontal plane. Latitude, matter of fact, on a globe is the surface. It's where the lines are drawn. I finally got your point.
No, yeah. I've got to interject. No.
Oh, shit.
No. Enough. Right. They're getting their angular change because of the curvature of the ball you're stood on and its rotation. Understand the derivation for the angular change of the object you're measuring off the flat plane. Now, even though you measure it off a flat plane, you can invoke the tangent, which is what gets Jeremy all juicy. Yeah. If you just take that point, yeah, then you ignore their claim. Yeah. Now, that claim is to invoke a tangent to the other point that you're looking at, which is their point of reference, which is what Brian's saying, which is non-attainable in their world by their admission.
I
More
see. Can I just try and
fundamentally-
paraphrase that back, just see if I understand that? What you're saying is, if you're going to take the inferred tangent to a sphere Earth edge, horizon Earth curve, and that tangent from that point isn't where they can only derive this angle from off a plane at a single point. So if you've got a Dingleberry Earth and the tangent at that single point is the plane that you derive for the angle, and it's not, or it eradicates their other tangent to a point below surface level that they infer as the horizon, to an contradictory, I can't think of the right word, but you can't have it both ways. You can't have a tangent point that's extending out into space to give you a latitude and say that you've got a tangent to a geometric horizon.
They can't claim a tangent plane or a claimed over 7 over or greater than 7 over 6 or horizon or any of that when referencing Polaris. Because Polaris is where our globe came from. Remember, flat Earth elevation angles to Polaris gave us the latitude and longitude grade. They turned that into a globe by making all the south ends of the longitude lines meet underneath the north end.
Sure. So I was kind of right, because what you're essentially saying is the globe burger and the Dingleberry Earth don't work with one another when it comes to ascertaining the original measurement. That would be Dingleberry Earth. Dingleberry Earth simply doesn't work. Why doesn't Dingleberry Earth work? Well, because Globe Burger is the original back-engineered functionality. Am I correct?
Let me make it even better for you. Just give me a second, Adam, please. Let me make it even better for you.
You're saying yes. It's the first time he said I'd got it.
Jesus.
Well, 1 second. Just let me just make it easier for everyone to understand. Right? Is Polaris one of the main or one of the navigational stars? Yes. Right? Don't need a yes. Just yes, it is. Right? Now, when they claim to navigate using their globe, they're going to be claiming tangent planes and 7 over and greater than 7 over 6 or nonsense to lift up the horizon so it's a horizontal with the water underneath that boat, which is going to be their tangent plane. So their tangent mirror is going to be the horizon mirror in reality. So what we call an horizon mirror in reality, that's actually a tangent mirror. But the point being is that they can't, when it comes to Polaris, so if they're taking 2 stars here and here mathematically, and they're going, right now, we have our 7 over or greater than 7 over 6 horizon, we do our little dip nonsense, there we go now. And when they go to add in Polaris, suddenly they can't do that. They can't claim a tangent, and they can't reference a 7 over or greater than 7 over 6. They can't claim any of that nonsense because they have to actually reference the surface of their globe. There's no way out of it.
Superchat!
Superfluid, supermodel, supercomputer.
That's Roger Ledwell. I am looking at my phone. Is it really there?
Thanks, Roger. Appreciate it. Adam, last comment on this, and then you guys want me to go to Brian's video?
I think that'd be nice if we could go. Like I say, it's rare to see something that reactive, that quick.
That quick.
And for
Okay.
Rufy, I've not seen it. I've not watched it. Just to finish on Brian's point, I think we've both got different points we kind of make, but I think we both see that we're trying to make Nathan grasp something. I think probably different points. In Greek mythology, when the guys are traversing the world and going through the pillars of Hercules and doing all these stories, there comes a point when they pass the equatorial point and they realize the stars are no longer useful for navigation because they're not able to use Polaris for its primary designation. And that's in Greek mythology. Go read it. And that's the point Brian made. All of these grid systems are based on the use of Polaris. And when we go past the point of distance from Polaris, or as a baller would say, the point of curvature, where it's no longer visible, then we have to invoke other things. And this is what they do on the ball, as Brian eloquently describes how it's then curved in. Relates to time bandits, because it's really important, as hopefully we'll show by at least 2027. I'm not having that QE, by the way. 2028, nonsense. How this curvature and pulling in is there, and how previous people have seen it, Tolkien included, as I've mentioned previously. So yeah, that's that. I want to see what they've got to say. So can we put that on?
Yes, we can. Thank you, Adam.
Just very.
Oh God.
Very briefly.
Let this continue. Hold on. I want to object to QE. Are you in some sort of rush?
I want to get past this point. You'll understand this at some point. We don't want to go for 3 hours on a refracted horizon point.
Isn't this what we do? We don't train to time.
We don't train to time. We train to standard.
Yeah. I mean, it's very rare that I'm in this sort of high degree of ignorance in terms of a point that I haven't quite picked up on yet. I mean, I say that when I've already disclaimed on this show that there's been points where there's been 6 months of, say it was other people, me whistling past points that I haven't understood and leaving a bit of dead air to move on to a segue. But my point is that in this scenario, I feel it's very beneficial to the audience. Now, when people are like critical of the repetition that we have on Flat Earth debate, because there is a very good reason why we do that, to keep the points fresh, to keep those points in the mind's eye of everyone who's watching. When it comes to this sort of subtle nuance, this is the very, and I won't decry it, it's the slow progress that we do take when we sharpen our wit and intellect in terms of these subjects. And they are details that maybe you feel don't need 3 hours spending on them. I do. Now, I just think that slow is the wheel that turns when you're refining something that's already pretty sharp. And I don't think anybody who's listening would go, well, Nathan really doesn't understand any of this stuff, does he? No, it's far from that. Not that I'm trying to defend my own ignorance in this regard, although I am doing exactly that. But I'm just saying, I just think when it comes to this, with you going, come on, let's get through this. Don't forget that you've obviously understood all of these things inside out and back to front. And I don't mind sitting in the seat of ignorance and saying, may it continue, with me being, oh, well, Nathan will get it eventually. We'll go back to it when dumb old Nathan can finally understand
That's
it.
not.
Thank you very much.
That's not what I'm thinking.
No, I don't think. We referred to it earlier as the Orwellian paradox, which we're all perfectly happy with. I think we understand. Apply it to all of their claims, I think, is what me and Brian are saying. Stick it with using dip. Stick it with you looking and measuring Polaris. Apply that Orwellian paradox and how your point of reference is non-referenceable.
Yeah, but that's what they do. They always compartmentalize it, right? They now say they never claimed you could see the geometric horizon and that sort of thing. It's like this compartmentalized conception of the Earth. It's how they think of the Earth, as geometric and spherical, but they don't see it. They don't get to see it.
Go ahead, Brian.
I hope that was recorded.
Yeah, let's go 5 more shots at it, Brian. You just want to add one more thing. Go ahead.
No, I'll try and make it even simpler. It's like this. When they're referencing Polaris for an elevation angle, and they're referencing the right with a marine sextant north of the equator, right, to find their latitude, they can't claim. This is the main point. They can't claim that the horizon we're looking at is not their globe's geometric edge. That's the point. So, and if it is shown to not be, which it isn't, their globe's geometric edge, that means the globe does not exist. Because
Yes.
our globe came from that exact measurement.
Yes.
That's where the globe was back engineered from.
Black Swan.
I know you understand this because you were the first person to bring it out.
Black Swan.
I know
the penny
you
is
do.
dropping. QE, the penny is dropping, Brian. I get it. It does tie directly back to the Black Swan and Arwinian paradox in that regard. If you're going to claim that it's a sphere surface that we're dealing with, it's got to be the sphere surface. That's your point, isn't it, Brian?
In this instance with Polaris, they can't claim a tangent, and they can't claim 7 or greater than 7 over 6 or any of the rest of it. Because of where our globe came from, where the measurements for our globe came from, right? Flat out measurements, but where our globe was back engineered from, it means the latitude and longitude grid. Look at Google Earth, it's on that, it's on the surface. So they can't, because that comes directly from Polaris. So when they want to reference Polaris, they must claim that the horizon they're using is their actual globe geometric horizon,
Exactly.
which it isn't, because that only exists in their maths. They can't claim a tangent, they can't claim over 6R, none of that.
Well, the trick they do now...
So now I've understood. I can now ask my question again. So how's that geometric horizon working out for you, Rufy?
Yeah, exactly. Yes.
Yes.
Well,
Triggered
now, right? I mean, the standard response now for a while has been, oh, we just don't use the horizon for navigation. We just use the vertical, and then they get around that whole angle. So just move around it. That's what they do every time.
Okay, so we're off. Nathan, you got it. You got it?
Yes, I am happy we have trained to a high enough standard now, yes.
Okay, so...
Before you press play, QE, only because I've said to if he said, Nathan can ask me on the Gerrans, or you can ask me here. So I just responded with the Discord link. He says, I'm well aware of Discord. Happy to meet any of you on a moderator platform. I don't know why a moderator platform would enable him to clarify exactly what we're saying. What's your claim, guys? And that was the point of tonight's stuff. This is their claim, geometrically. I'm showing to you. Not 8 inches per mile. If you want to be accurate, that's what they're held to. Now, when they try and level a device, they level it to something that isn't, as they will definitively state, thanks to Fight the Flat Earth, you know, when you're holding a cigarette in front of your face, it's not really right there. They make that statement because of refraction. They'll always say that whatever you're looking at isn't wherever it is. And that's their leveling device, something that they don't know where it will be and what that level will be when they level it to on any particular day, unlike us. And I'm happy to end with that claim.
We're dealing with retards here, and this is another retard. Where's Wally? That's a perfect name for your dumbass. We're going to go through this. So this is going to be more or less a impromptu treatment. So you guys stream him out.
Press play.
Huh?
Before you press play. No.
Oh, no, let me do a call to action. Oh, no. If this could be an impromptu treatment, let me do a call to action. Hello. You share the show. If you're watching, how many people are in the live audience, please? If you don't mind.
I have no idea. Hold on a second.
If you are in the live audience right now, right, this is where you want to smash that share button. If you don't normally do so. We don't normally do impromptu treatments in the middle of a Ballbusters, but this is going to be epic. So please share the show if you've not done so already. It's like 2 clicks. You press share. It says where, Facebook, for instance, and then you just press Facebook. That's it. It takes you immediately to your account, opens it all up, and then technically there's a 3rd click to actually press post. It's really easy. It's like, I shouldn't say 2 clicks. It's 3 clicks to share the show. Really easy.
We got 82.
82. There should be 100 people watching by the time we get to the crux of the treatment and we're into the nitty-gritty. There needs to be 100 people watching. It's up to you, the live audience members, to share it.
Yeah,
yes, up to 100.
We got Superchat, Superfluid, Supermullen, Supercomputer.
I must have missed this one. This is another one from Roger Ledwell. You don't really need the ground.
Yeah, exactly. That's the reference to the whole celestial navigation bypass. We don't use the horizon or the ground. You just dangle something vertical, and then you take a 90 degrees to that. It doesn't have anything to do with the geometry of Earth. It's not involved, right?
It's not the ground.
It's not the ground.
We've been navigating the ground. Now it's the ground that's flat. It's not the ground.
Exactly.
Okay, is everyone
you
in
don't need it
Discord?
anymore.
No.
If it's flat,
brother.
you don't need it anymore.
let Owen go then. Before you press play, I know I'm a stickler for detail, but Owen, off you go, and then.
Well, he was done.
Oh, good. Then I can start. Cool. So, see, the first thing that strikes me is wolf pack, right? Huey, I hope, you know, and your wolf pack pays attention to detail. I wonder if your wolf pack would present a logo with a bear print underneath the name Wolf.
Epic.
Oh, God. Oh, brother. Where's Wally? I'll tell you what, sir. You freaking retard of the ages, man. And Adam, I wasn't even looking at that. I'm more or less looking at QE, Brian, and Nathan comedy. They didn't even put your name up front.
If you're going to presuppose, at least be accurate.
All right, here we go. You guys tell me to stop it, all right? Volume should, let me check the volume, make sure it's good. I need to go on mute a little bit. All right, here we go. You guys holler when you want me to stop. Here it is.
I wasn't calling you as thick as an Australian, I promise. This could be the only intonation you could take from that.
And he took
racist.
It.
Yeah.
Yes, and he took that. Yes, he's Irish, for God's sake.
Yeah, well, I'm naturally thick about things. But no.
You're not. What a garbage statement. Right. Over the last week or two, I've had to disclaim where I sit in fear of your intellect as it's greater than mine in many, many examples. And here you are going, oh, I feel...
I stopped it right there. This looks like a big nothing burger, Adam.
It's that scene in Spaceballs where they go up to the monitor and they're looking through the timeline into the future, and then they stop at the point where they're looking at themselves, and they look back at the camera, and they look back at the monitor, and they go, what are we looking at? Well, we're looking at the bit that's being made now. This is us responding to a video about a live stream that's currently being made. This is insane.
There's nothing. There's going to be nothing here, Adam.
Well, give it a chance.
Were you expecting anything? Were you right? So the point being, were you what would it have been?
Nothing.
I don't know. But what's happened is that Wally has made a video. He's bothered to send a message to Rufy to go, shit! Yeah? Right. And then Rufy sent me a message to try and goad me. We've played the message, and what we're seeing now is that the message that they're panicking to, their distraction technique, has got nothing to do with addressing that geometric horizon that Rufy's so scared of. And that's lovely, because if all we want to do is recognise what they're prepared to do is that Brian bothers to read more than Nathan, then well done. I think Nathan had said that before the show, guys.
So,
well,
hold on, Brian. Let's just get to the end of the clip just to see if he comments or anything. Just
they ain't going to do anything with this.
Play it.
All right, here we go. I'll finish it up.
Think about things. Yeah, get lost.
No, that's thick is like stubborn or awkward. Stubborn or awkward. It doesn't mean that you're smart or stupid. It's just if you're being thick about it, you're being stubborn or awkward. That's what it means.
No, fine. I didn't know that was. I'll take it completely back then. No, I'll take it back. Take it back.
Yeah. But by the way, I'm not. You keep on saying I have a better intellect than you. I don't. It's that I put in the effort to learn the details, and you don't. That's
and you don't. That's a good one. I like that one. And you don't. Good one. Okay, so specifically with this, that's it.
What was the point that they're making? That I'm lazy? Is the point that I'm lazy?
I don't.
Is that not the point that you've admitted on multiple times, and why you say thank God for my panel? That thing that we all know and agree, because we don't have the effort We've got the time and the luxury of doing research, yeah, not running a show. And dealing with young kids, frankly,
I'll defend.
the
Right.
point I'm making is we contribute as a team, and you have always actually admitted, thank God for my panel, you did it the other day, and these are the guys that do the work. They've bothered to do the long hours of reading. The multiple times over the past year, you've said, thank you for banging on to me, Brian. So is that what they're pointing out, that your humility over the past year, they've recognized? Is that their point?
These are all great
Nathan?
words. It's not laziness. This is what you call positive spin. I say laziness. No. Humility. Love it. Love it.
You trying to hold on.
That was
Hold on. You trying to discern the motives of retards, Adam? Is this where we're at now? Because this is a big nothing. This is a nothing burger of nothingness.
Yeah, and trying to discern the purpose of the video. It appears to be an add-on to Nathan that he doesn't research.
Yeah.
Where in actual fact, it's an admission of what he's admitted over the past year. Yes, he won't bother doing the long hours of research. That's what we're here for, the panel, right? But when we keep banging on at him, he will listen. I think you've heard that tonight. He got to a point of confusion where he wanted clarity. He pushed the point for us guys that have bothered to research for it. Well done, guys. So we've got standards, have we? And actually, Nathan doesn't cook and go, oh, yeah, you guys know more than me, so I'll just go, oh, carry on. No, he stopped the show and brought it back because he didn't understand. So I don't get the point of attack. If anything, I say it demonstrates standards, something a lot of people get.
The attack is on me, not on Nathan. The attack is on me, not on Nathan.
Oh.
Brian probably feels put out because in a scenario like this, Brian's spending a very long time researching ingredients and finding out how the ingredients grow and how they should all be put together in a recipe, trialing out that recipe, finding where it fails, refining a recipe. I come along and go, that smells nice. Can I learn how to cook it? And Brian goes, yeah, if you put in the time and effort of learning how these carrots taste nice. And I go, nah, you've already figured that out. Can you just show me? Brian sighs and shows me. And I go, I still don't understand why the carrots are so tasty. And then Brian has to drag me through the bush backwards as I'm going, I don't really understand over and over again. But for the fact that I've got exceptionally good teachers, I can be taught the refined shorthand understanding from exceptionally good teachers. Well, without putting too fine a point on it, that is a lesser quality understanding, isn't it?
Oh. But it's not about you, Nick. They're not attacking you in this. They're attacking me. Wally in specific is attacking me.
I'll go on. How are they
Super chat. There's a super chat came in.
Super chat, super fluid, super mullet.
Yeah, I kind of just sang it a little bit. It's Roger Ledwell again. Bear is too greasy. Okay.
He's back to that bear claw. All right, so I want to know. Thanks, Roger. I want to know how this was attacking you, Brian. Please, floor is yours.
Because I continually hold them to task on all the things they don't understand about their own paradigm in my videos. And Wally, in particular, I highly embarrassed him just through comments when it came to GPS. But Wally tries to see it the other way around. Even though I proved to him that what I was saying was correct, I proved to him that they had compasses and all the rest of it with it. He has to see it the other way around on that issue and other things because he can't see it as him being incorrect because that means everything he's been told is incorrect. So when I say I learn the details, you don't, Nathan. What they're actually doing is attacking me as in Brian learns the details. Yeah, right. That's what they're actually saying. It's an attack on me, not on Nathan. As in...
Fair enough.
Oh,
that makes sense. I was going to say, if they were attacking you, wouldn't they have just taken a Pythagoras... Sorry. I was going to say...
I'm just saying... Go on.
was going to say, if they were just outright attacking you, wouldn't they have just gone and took your disclaimers of education status when it come to Pythagorean calculations that you disclaimed you hadn't done? But now you've actually explained it. I do see what you're driving at. They're having a little dig between your ribs. That example. Maybe we're reading between the lines. On the other hand, I do actually take QE's inference from this. This is a total nothing burger.
No, it's not a nothing burger.
It's just a nothing. It's an ad hoc.
It's not a nothing burger. It's feebly executed ad hom fallacy by Tootsie Roll Dick Globetards. That's it. It's silent. It's a silent movie. That's it.
It's a panic button, isn't it? What does it mean? What's your purpose? What did you demonstrate when you cut this out?
Nothing.
I've got no problem being held to account in any way. Yeah. But if you're going to do that, well, yeah, please put my name before Brian's fundamentally. But outside of that, what? What's your point?
I think it's attacking you, Adam, for not knowing the difference between Australians and Irish.
I did know the difference.
And I just want to point out...
rules. I know they don't know how to use a calculator in general. I'm also aware of Brian's upbringing, that as intelligent as he is, actually, some of the more fundamentals of fucking around with trigonometric functions, he didn't bother. He was doing stuff that, I wish I was doing as a kid. You know what I mean? We're a team. I don't need... Yeah, what they're desperate to do is try and drive a wedge. Yeah, there is no wedge. They've tried to do there with you two. It's pathetic. What's the point?
No point.
They're promoting their bear pack.
Yeah. No, let's just keep Adam's point going. There's no I in team. Therefore, if everybody does a little, I can find out after the fact once you've refined it all.
I remember many years ago you saying, everybody does a little, I don't have to do a lot.
Exactly. That's fine. We're going too... Hold on. We're going too far. Get the hell out of here. Change the topic. Because I shouldn't even play this horse shit.
But the topic and the point wasn't it, that fundamentally we've done a live show talking about curvature and how actually they're held to their claim. And here's their claim geometrically. That thing, yeah, and we've pointed out certain things that they managed to calibrate to this geometry that they then move. Yeah? And within us showing the rigidity of that geometry, we've had a reaction video while still making our video. And that reaction video was so piss poor weak, it's laughable because no one really knows what it was on about, unless it was racist to the Irish or Australians or just another ad hom at Nathan. We don't really know. So poorly composed. But that's the reaction. The ballers are on it to the point that somebody's made a video, contacted Roofy. Roofy's bothered to text me and say, "Hoo-hoo! Yeah, calm down, girls."
There's a message for Roofy. I think Nathan had the message for him. What was that message again?
How's that geometric horizon working out for you, Roofy? Is it good? Yeah? Is this a response to that question?
See, there's the trouble. I have worked out that geometric horizon for you, Roofy. And that's the flipping trouble, isn't it? Because now that hill is defined. Yeah, it's in the way.
Go ahead, Brian.
Move it back.
Go ahead, Brian.
Yeah, I'd just like to say that Adam attacking Australians is only Adam in jest. One of our most respected members is an Australian, and that is Mikkel. So Adam is just having a joke there. We love Australians.
You speak
in the interest of balance, Australians are dumb AF.
The reason it says Aussie rules is because back in the day there was me, Savage with his gyroscope, Rob with his B whatever camera. We didn't have a P900 then, taking stuff, looking at all these things. And he was the same. He was a practical man that wasn't good with stupid trigonometry functions deriving formulas. And like you do with your mates, you take the mick. Yeah, it doesn't mean when you put those things, you're decrying their intelligence. You're just telling them how simple something is. It's not just because it's got the word cosine in doesn't mean it's actually complicated. Just another button on the calculator. There's nobody, me included. I can't not press the cosine button and then work it out myself.
Well, one of the reasons they maybe didn't jump on that part is because I'm very open about my education. Because from the start, from years ago, because that's something they'll use to attack you. But once before, I was attacked by a couple of the ballers because I didn't know how to do square roots in maths. And one of the ballers that attacked me was Lieu. And Adam said to Lieu, if he says, "Can you do square roots without the calculator?" Silence.
Yeah, exactly.
You gotta know though that's a good example because if you don't know to ask that of somebody, because what went through my mind when you just said that, Brian, was what you don't have to press the square root button, right? Because that's as far as my mathematical intellect takes me. But to be more advanced in your mathematical understanding would be to know that perhaps knowing that that's how you would probably do it would perhaps infer that the person asking may not know how to do it and it might be worth asking. That takes somebody with a good mathematical understanding to know where their opponent might be failing, yeah, and call them on it in the moment. But you've got to have that confidence. Well, what Adam's done today is there's no way, even if you'd have completed high school maths, GCSE level maths, there is no way you'd have been able to do what Adam did today. I mean, I'm not saying it's degree level mathematics that Adam's done, but very easily BTEC/A level standard to do what Adam's doing. And there's a point where I'm going in a minute. What your opponents will do is pick on your mathematical weakness and then present something similar, not the same, but in a similar sort of complexity to what Adam will present, because they know they'll baffle you with it, because you've got a weakness in that regard. Now, me, you, a lot of people would declare the same weaknesses in terms of maths. And there's a good chance, I bet you anything, you're far better at maths than I can't divide meters into kilometers. You know what I mean? The point is that they'll look at a weakness that you may or may not declare and try and have you over a barrel with something that is far greater in complexity than average Joe could ever achieve. And this is the standard with Adam here. What he's done here, as I say, is beyond the general standard of mathematical education, like considerably above. I wouldn't say, like I say, you would not call that degree level understanding of maths to achieve what you've done today if it was presented as a quiz. I can very easily see what Adam's done. Forget sphere Earth, just the maths that we did, or Adam did. So I immediately said we there. Anyway, Adam did at the beginning of the show is something you could easily see as being a quiz. You know, calculate the distance of this curved line using Sokotoa or something like that, and give us a correct value for that distance. Well, that would be, what would you call that, Adam? Maybe A-level maths level? Beyond your average Joe, definitely. Wouldn't you agree?
I think it's an A-level maths quiz to derive what I derive. It's about A-level level. It's above GCSE, but it's not degree level. Because I've only got an A-level in maths. I've not got a degree in maths. I enjoy it, but yeah, it's about that level. It's certainly, and this was the point, fundamentally, you see, why I objected to 8 inches per mile squared, because that's GCSE maths, guys. It's made more complicated, but fundamentally, the underpinning maths is A squared is equal to B squared plus C squared. Yeah, Pythagorean theorem, not trigonometric functions, which are more accurate. But it's certainly not degree level. No, it's there and it's obvious, because it's nothing to do with flat Earth. It's basic maths geometry, which I enjoyed as a puzzle. But no, it's not degree.
Super chat.
Super fluid, super mullet, super computer.
Roger Ledwell, he sent Bob and Bev sitting in a tree.
Bob and Bev. Talking about pseudoscience fallacy guy, Bob. Thanks for the super chat. Appreciate it.
Do you call what George Netrick did degree level? His derivation.
Yes.
Yes.
I would also.
Yes, because what he did was, and listen to the start with regards to the assumption. So he builds a cone, and then he draws parabolas to the cone that intersect some of the curves. And it's that point of intersection with some of those curves, and that particular intersection of that particular point of the cone that these parabolas, these planes are intersecting with to create the parabola, that you then compare to derive your 8 inches per mile squared. Way above what I did. The interesting thing is why then, if it's above that standard, and I can then derive something that's more accurate and something that Metabunk uses in his computer programs and takes that function with other things to apply 7/6R or or Bislin does the same thing. Why did they originally begin with this parabolic approximation due to a plane drew through a cone that is approximated over that 200-300 mile distance as the same as a circle with an R value? Why would you do that unless it is just, as we've always said, that rule of thumb? Something very simple that actually in reality practically applies, so that's fine.
Right. Yeah, so you can give a rule of thumb to Dumbos, absolutely. So you can just throw it out with just the distance value, and there's very little to actually need to apply, and it will almost work. Yeah, work well enough. What I do remember with George, and to actually do that, what it's quite a number of years ago that George actually did that, but I do remember watching him do it, and his explanation was sufficient for me to follow along and understand what he was doing. Now, obviously, to have somebody who is clearly degree level in terms of their, number one, recognition that they need to explain why this is being done and how it does accurately, according to George, match up with the sphere enough for you, the numpty, to just take the distance and make the assertion with 8 inches per mile squared. Here's the justification. And because he's a good mathematician, he could boil that down to simplistic enough terms during the explanation that I, a complete novice in mathematical terms, could follow along and understand as he did it. That took quite a high degree of skill. If he was here, he'd be listening to this blushing, wouldn't he? Because I'm really, really complimenting him. Yeah, for me to be able to follow along with what he did and discuss it. I vaguely remember discussing it with you again after the fact several years ago, Adam. That was probably in that show that you brought up that I can't remember the name of.
There's not one part of that derivation that I disagree with. The points I disagree with are the assumptions that are made. Yeah, which I think I've outlined enough. From a mathematical point of view, everything that George outlines and goes through is I've not got a point of disagreement with. Spot on to derive something which is an approximation. To express it in a way that is simple, i.e. in a Pythagorean way, as opposed to a more complex way. Yeah, nobody in their head has got a book of cosines. Most people can square a number. So if we resolve it with Pythagorean way, i.e. a squared equals b squared plus c squared, and we use that principle, even though we know a squared isn't a straight line, and we ignore the variance because of so biggie. Remember that, and then this is the point of mitigation. The same with 1.2. 2 times the square root of the observer height in feet. That has mitigation because Earth's so biggie in it, R minus RH. But if you ignore that, and it's not ignoring it because in the maths it's declared, and George does that, then everything he says is spot on, accurate, and kudos to him. To be honest, he's a better mathematician than I.
But now let me pull the rug under Adam's feet, because it was the point he was so keen to stress earlier before he got drunk, which is to say that when you give them an inch, so many inches that they'll take back to flat, isn't there? So in terms of the accuracy, there's no reason why they shouldn't be accurate in terms of what they're trying to express with their maths. But in this instance, with a justification for, well, it's just easier to give this formula in a squared, what is it, parabolic function to Dumbos to just express with distance. Here's how complicated my maths gets from George Nettanyuk in his explanation for it, which was perfectly adequate, in fact, very good, to justify that inch that they're taking in terms of the geometry. Well, what's the next step? It's add in refraction. What's the next step? Make the refraction infinite. What's the next step? You give them an inch and they take another inch and another inch and another inch and another inch. You at some point have got to get into the nitty-gritty of what they're actually claiming and hold them to task on it. And that is where, for those who would disclaim that maths is basically God and right in all instances, well, let's be accurate about it then. If you're going to make this assertion, let's make sure that we're tying up what you claim to what is actually aimed to be a physical sphere that you're standing on. Not well, for a Dumbo to make it make sense with only a distance, in a squared function, it's kind of like this. Oh, really? But working to your advantage so you can fudge the numbers. Right, Adam?
Remember why? So when George brought this out, it wasn't Lieu that attacked it, because I think people like me looked at it and went, they're playing. And I think, and this is so old, this vid, that QE's remembered it and pointed out and said, I actually like that video. Because that's how you presented it to me, QE, yeah?
Yes.
Yeah, I've got no issue with that, and I don't think we did. The opposition to this video was the ballers. Why? Because even though I might have a disagreement with his rule of thumb approximation, it ties them to a geometry. It's not quite 6/6R, but it's nowhere near 7/6 or 8/6 or 2,654/6R for the Black Swan. Exactly, yeah? It ties them to a geometry. And fundamentally, it removes the excuse that you can go hand wave dismissal. Well, 8-inch small squared, it's not accurate, is it? Yeah? It removes that excuse.
Sorry, Adam. I thought I had him weigh in.
I did my usual, didn't I? Finish and then finish again.
Where QE is, but
Superchat, Superfluid, Supercomputer, Supermolid.
okay. Roger Ledwell again. He said Maltese Polans.
I know what he's doing. Shout out, Roger. Yeah.
You mean Modus Tollens, or it was a joke, right?
This is a joke. It's directed towards a certain individual that's retarded.
But that's the point, isn't it? That's their claim. Modus Tollens.
No,
I
this
mean
is
lovingly retarded, right?
This is Maltese Pollens. MOLTES POLLENS.
Even though it was late, that super chat, it related to the point I'm making, yeah? And that's why George wasn't liked, because he holds them, Rufy, yeah, whether it's an approximation or not, to a geometric limitation.
Yes.
As defined by them, not us. Not us.
Yes, sir. You got it. All right, listen, it's getting close to dinner time. I'm getting a mite peckish. This was a great presentation, Adam, really. It's outstanding. I'm going to take it with a grain of salt. I think it's going to confuse some people, but you are correct. That is the most accurate. When I first seen it, during this presentation. I said, oh, no, I see what he's doing. But kudos to you, sir. Keep an eye out.
I'd just like to say.
Okay, go ahead. Go ahead, Brian. You got something, last thing to say?
Yeah, the way Adam did is the way I would have done it if I knew how to do it. Thanks.
Very well said. That was really good, Brian. Keep a weather before Nathan takes over and takes us home. Keep a weathered eye and a weather out for the next treatment. It might come up pretty quick on you. So just that in mind. We have Bob the pseudoscience fallacy guy, and OMG, that friggin' planet Peckerhead. You need to do a 180 and start boot scooting, dude, because you ain't ready for what's about to come down on you. Nathan, sir, take us home.
With that, I'll say, first and foremost, a huge, massive, enormous thank you to all of the BALLBUSTERS panel for making today's live show possible. And, of course, a massive thank you to all of you in Quantum Eraser's live stream chat for smashing the super chat, hitting him up on PayPal, and all that good stuff. I am going to post a link to the video that may get played as we round out this stream, or got played at the beginning if he doesn't, and that is called The Sun Proves the Earth is Measured Flat. And that is a video I hope you all go along to and like, comment, and share around, as it's so fantastic, according to QE. I didn't know I should so heavily plug it. Of course, a massive thank you to Quantum Eraser for making today's live show possible. I've been Nathan Oakley, and we will see you all in next BALLBUSTERS.